No me preocupes. Más tranqui. Sí que es verdad que quizás no lo ve tanta gente, pero más relaxed.
Vamos de a uno.
Bueno, voy a ver.
¿Cómo te llega el 1?
Pero es que claro, no hay ningún cartel que ponga que hay un workshop. Es ahí, o sea, es ahí detrás.
Y hay un headset hablando.
¿Y hay gente todavía?
Sí, hay un par de personas, pero no. Buenos días, sí.
¿Cómo estás? Un gusto.
Hola.
Yes.
Ah, ok, perfecto. Bueno, les estaba contando a los chicos que yo soy la fotógrafa de Open Zeppelin, así que los voy a estar siguiendo un poquito.
Perfecto.
Si ves la cámara muy cerca, no te
Sí, no te
preocupes.
preocupes. The workshop is actually going to be somewhere in there.
¿Puedo escuchar ahí por el auricular?
Yes. Like, it's
Pero
like
llega ahí...
the AI is starting to control
Sí,
me.
te llega.
Yeah, so there is going to be people actually like talking here. The workshop is there.
You just need to talk a bit louder.
And you have headphones.
Okay. But like, I'll try not to ask any.
No,
weird
try
questions.
ask
Like,
cool
where's
things.
your jacket?
My jacket is there. They gave me a cool
With
jacket.
shiny things.
No, not the shiny things.
I would love to get a jacket with shiny things. Do you think you can get one
Probably.
shiny for me?
Yes.
Because that's to play on stage. I have concerts that you need to be a bit more
Yes.
formal with something like that.
But they say like trustless on the back.
I don't care.
You don't give the back to people on a stage.
Estamos haciendo pruebas. Así que...
All right, I'm gonna go back and we can see if there is actually gonna be people there. Morning, Luis. Morning, Orcam. How are you doing? Yeah, doing great. My worship is gonna be backstage, which is weird. Like I'm doing a workshop right now at the same time like Barnaba is talking, which is kind of a weird organization situation. But yeah, right. See you around, Orca. Hello.
Hola. ¿Me escuchas? Hola. ¿Sí? Pará, te doy un coso, pará. Hola, sí. ¿Y el micrófono? Hola. ¿Te llega? Bueno, escúchame, ahora voy a habilitar los dos un toque, ¿están hablando?
O muy haters con OIF.
Publicly?
¿Cómo te llega?
Wow.
Very publicly. O sea, no con OIF, sino con intents.
Okay.
Bajo.
Well, it's not the same.
Ok, listo.
Pero claro, o sea, el Ethereum Interoperability Layer es muy de exact
¿cómo tenés el volumen
transactions,
ahí? Pará.
exact things. Y trabajan mucho en privacidad, trustlessness y todo esto. Entonces, la comparación son los intents y very actively attacking them.
Well, we'll see.
No, no están hablando, tranqui. Pero igual el micrófono me lo escucha bien. Listo. Igual. No, está.
reflect on that in a moment. And then this is a framework. A framework means that even though we are giving or we're developing tooling, it's not a product by itself. It's a framework for other companies and other protocols to build on top of. So we've been developing reference implementations for most of the components, but the idea is that this serves as a common layer for people to build on top of. All the components have been very modularized. It was very important for the OIF framework to be very modular, very compatible with new protocols, and being able to facilitate integration with protocols that may have their own complexities. So what is the benefit of OIF as a framework? The main benefit is being able to plug and play new components, new wallets, new networks, new protocols very easily with the same API. So imagine we have an ecosystem where multiple wallets are compatible with OIF, multiple solver networks, which we will go in a little bit on what a solver network is, operate within different networks. Now, if we have a new wallet, this wallet is automatically able to interact with every single piece across the stack because of the common APIs and modules. If a new protocol wants to run a solver and operate and provide liquidity and do things, it's also very easy for them to just get running and get exposure to all of the wallets straight. Chain mainly, but there is already standards that we will go more in depth later to put that intent on chain and for solvers to pick them up. Once the intent has been opened on chain, that can be done either by the user directly or by the solver opening on their behalf, the liquidity gets screwed. The OIF is very modular in the scroll options. You can have a direct scroll into the smart contract, but you can also leverage resource logs for doing this. Resource logs, you can research much more onto that, but it's basically a technology that allows you to have a common liquidity pool that just by doing signatures can be moved with the help of a off-chain party. Once the liquidity is properly secured in a contract, in an escrow, the solver then fills your intent. So you straight away get the output money. This is done through an output settler contract, which is also very modular and allows you to do further actions once the intent is fulfilled. It's not just transferring a token, it can be transfer a token and call a contract and kickstart a chain reaction of different things. This action will create a proof that an oracle has to then forward back to the origin network for the solver to claim the assets that they now belong to them. This Oracle is also very, very modular in the way that it's structured, and it allows solver networks and users to adapt to the protocols available to them, but also for the trust assumptions required for different types of operations. You may have smaller transfers that you're okay with using a centralized Oracle, while if you want to move like $5 million, you may want to have like a more secure Oracle that ensures full completion and full trustlessness. I'm pretty sure the two voices in your head also are pretty disturbing, so sorry for that. So what is Open Zeppelin building? When I was thinking about this, like, where is the camera? Hello. You remember the Steve Jobs iPhone presentation? Like, it's a phone. It's an iPhone. It's like three things in one. OIF is kind of on the same vibe. So I'm not gonna do like Steve Jobs wannabe. I'm very far from that. But OIF builds on that same ethos in the sense that we are building reference implementations on everything that is required through the protocol. So we are building smart contracts, which is the core kind of base of the OIF. It's an on-chain protocol and should always be fully available on-chain. We are building a solver which allows for new networks to like just take them, run it, provide their own liquidity, and get started as part of this ecosystem without having to go and talk with other providers. And we are building a REST API to facilitate a standard way for communicating with that solver. When we build all of these things, we also realized that wallets will have to connect to multiple solvers to get more quotes. So we also built an aggregator that I will explain a little bit later. So smart contracts. Smart contracts we are doing in collaboration with LiveFi. So something that is very important for IF is like it's not just Open Zeppelin. It's a Ethereum Foundation like project that multiple projects are collaborating into. It's not just Open Zeppelin. So smart contracts have been collaborated along with LiveFi. They are the main core contributor. They are very, very modular and extensible. We have like the input and the output contracts, and they all allow for extra actions and very like customizable approach to things. They allow, as I said earlier, for like kickstarting a chain reaction, where when you complete your intent, you can call with a specific data to a specific contract, and that may kind of start another intent or do more things on other protocols. It's also very modular, both in terms of how the money is secure and how the validation is proven. So right now we have support for resource locks, and we have support for direct escrow of tokens, either through like Permit 2. We have also support for 309, which is also a signature protocol a signature standard to facilitate signing. And for oracles, we actually have like 5 to 10 different oracles, and the list is just growing because we've seen a lot of interest from oracle providers to be integrated into the standard. So this modularity allows for users and protocols to have a very clear trust assumption among them. So you may have solvers that prefer some oracles, while others like have a lighter requirements for trust. We are also building the solver. The solver is the primary off-chain component. It's the component that actually fills the intent and the component that handles all the liquidity. It's built in Rust, the reference implementation, and it's very modular to like configure every single detail that a solver may want. So you want to adapt how fees are applied to your project. We have a module for that. You want to adapt which oracles you support. We have a module for that. So the idea is that these solvers is a base for projects that are actually going to be running this to adapt their own needs. It supports the OIF APIs, and it facilitates basically all of these management. It's very modular also in terms of which network and token it supports and which kind of actions are provided. So a key element in this is that a solver requires like context and estimation of gas on the intent that they are fulfilling to provide a good quote. So they need to have a clear trust assumption and a clear view of what's actually going to be executed so that they don't get drained or they don't get messed around. This REST API, I think I said too many times, like it's modular and extensible, but like it's really the foundation of this project. It's a very modular project, and this API is minimalistic at core, but extensible to the maximum. Basically, we provide classical metadata as like, what do you want for input? What do you want for output? Is there any trust assumption you want us to respect? Like a specific oracle that you want to blacklist? Is there any like pair of tokens that you don't want to touch? Is there any time to execution that you require? And all of this gets formed into a quote, submits to the solver, and then the solver will give you all the data needed to sign to then propagate that intent. All of this is obviously a little bit complex to do when you are having to communicate with so many different solvers at the same time. So we built an aggregator. An aggregator that again is modular and extensible, and it also has a unique capacity that other than, or on top of being able to aggregate multiple OIF API solvers, we can transform the API to connect with other protocols that may not be fully OIF compatible right now. And we are able to transform their API calls to make it transparent to the end user. So OIF does not only support or does not only work for pure OIF protocols, it also works for other intent-based protocols. So now we are going to do a little bit more of a deep dive with Fran about an ERC that we've been working on together.
Okay, can everyone hear me? Well, yeah, awesome. So ERC 7683 is kind of its own thing, but we are working on it as a part of OIF. And in order to understand why it makes sense to have a standard, I want to take a step back and give an overview of the life cycle of an intent, which Pepe brushed on, but this is a bit of a more simplified view. So at the beginning, you're going to have a user. It's going to be interacting with an application, and they're going to express some intent, which is some outcome that they want to see affected. The app or the wallet are going to synthesize from that an order that implements that intent in some intent protocol. And that means that it's going to sort of verify that the intent is actually achieved. The user is going to get this order back, they're going to sign it, and then they're going to submit it to some order feed, which could be on-chain, could be off-chain, and from this order feed, it's going to go to a network of fillers, which are the ones that actually will kind of make sure that this intent executed on-chain. So that is the last arrow that we see right there, the fill, in which the filler will interact with the intent protocol or the settler contracts of the intent protocol to give the user their assets and then to verify that they did that and then get paid and so on. So the problem and the context in which the ERC comes in is that this last arrow that we see, the fill, is protocol specific. So it'll be each intent protocol will have a different interface, maybe even sort of a different structure of things that the filler has to do to get their payment, or values that they have to provide. And so what this implies is that every filler will have to integrate with every intent protocol separately. So they will have to write up the solver that we're developing. They will have to make their own solver code for the intent protocol, or use the one that's provided by the intent protocol. They will have to do separate audits. They will have to set up infrastructure that's specific for that, maybe connect to some off-chain service. And so it'll all be very protocol specific, and that's a lot of work that needs to be done, right? It's development, it's reviews, it's audits, and so the consequence that this has for the intent ecosystem is that it raises the barrier for a filler to participate in an intent, or for new intent protocols to come up, because it's very difficult to bootstrap this network of fillers because of all of that work that needs to be done. So the goal and the ideal that the ERC is going for, and that the authors originally sort of saw a problem and wanted to solve, is to say, well, can we have a standard whereby fillers just sort of are agnostic about the protocols that they are working with, and when someone comes in and they develop a new intent protocol, they can sort of get for free that filler network, and the filler can also get for free the order flow that goes to that intent protocol without doing so much development and specific integration that is currently required. So with this motivation, in April 24, Across and Uniswap got together and they built ERC 7683. It got a lot of interest from the industry, and we saw it a lot in like crypto Twitter and all of these logos, which really means that there really was something there. So they worked on it all throughout 2024 up until 2025. But as protocols started implementing it, they started to find that it wasn't really optimal. There were many things that weren't quite right with the ERC as it was originally spec'd. So we're going to go over first. Going to go over some of these things that could be improved. So this is a part of the ERC. It defines some structs to encode orders. It defines functions to initiate intents on chain. And there's a few more things that are in the screen right now. And the problems that these three main problems that the ERC had that implementers sort of discovered were, first, it sort of forces a lot of gas overhead in the intent flow. The two things that I highlighted here are that there are these really big structs that you have to submit to the open functions, and then this even bigger struct, the resolved one, that has to be emitted as an event. And this is a lot of gas overhead. And I think, we talk about gas a lot, but in this particular case, it's really interesting because, protocols often compete in having the best gas efficiency for their users. And if we have this standard that, it's very, very pretty and, standardized and whatever, but it has so much gas overhead, nobody's going to use it. So it's not really achieving the goals of standardization that we're after. So this was a really, really big problem that V0 has. The other problem is that the interface was designed in this escrow-centric framework, and I mean escrow here in the sense of Across, which is the first one sort of that Pepe mentioned, which is when you have to make a deposit on chain before you then go ahead and do the fill on the destination chain. And as also Pepe mentioned, there are some newer constructions such as resource locks that don't need that step, that provide potentially much better UX for users, and that we would also want to kind of fit in this standard. And so, in addition to this point about the lifecycle, there's also some parameters there in the order, such as the open deadline, that are included that, again, many protocols won't need. And like I said, it's adding gas overhead. So we've got this kind of thing where it's sort of pushing many protocols away from actually being compliant. And lastly, point 3 is that the ERC actually kind of realized that, well, there is this variety of protocols out there that is quite natural, right? Because if you're building a protocol, you want to do something innovative. You want to make something different with your protocol. Differentiate yourself from the rest of what's out there. So you're gonna have your own protocol-specific things that you want to build and to offer to the user. So they included this kind of very generic bytes order data thing inside that actually ends up doing a lot of the work of like protocols being compliant. You just have whatever it isn't standard, you just shove it in there, and it looks like it's good, but it's actually, you end up with something that's sort of only semi-standardized, because every protocol is going to end up defining their own kind of order data, and you're sort of back where we started, where every filler has to still integrate with each of these different things. So I'm just going to go over a few more issues that this standard has. This is sort of the other half of the interface that the standard defines. And I'm just going to, first problem listed here is that the proceeds and the costs of an order are only really approximated, and in some cases like extremely coarsely. And this is the max spent and min received parameters there. And you should understand that it's very important, these things, right? Because when the filler, they're subscribed to this feed, they get orders, and they're going to sort of analyze each of these orders. They're going to assess whether the order is profitable. And if the order isn't profitable, they're going to drop it. And so representing the proceeds and the costs very accurately is really important, because if you don't, the filler is going to most likely just drop it, or be taking on more risk than they would be comfortable with. And again, this ends up with like a dysfunctional network of fillers, and that's not what we want. So the second point here is that, like I said, we've got some extra parameters, like the open deadline, that some protocols don't want, but we also have some missing parameters, like the settlement deadline in this resolved order, which is very important, and because it implies like, if the intent hasn't been filled and settled at a certain point, the user wants their funds back, right? And I want to stop here and sort of point out why it's very important to give all of these parameters. Is because these orders, right, which the filler signs, which the user signs and the filler receives, are really the coordination mechanism where they are, agreeing to very important parameters, and the funds of one will be locked in one place, and the other one will be sending funds to some other place and sort of hoping that everything resolves. But no, you don't want them to be hoping. You want them to have certainty that they're going to get their money back, right? And so parameters such as this settlement deadline that ensures that users can get a refund if the intent is never filled are very important to include across the standard. And finally, two more points are, this was built at a point where we didn't really have any good standards for chains and addresses. So in any multi-chain setting, you need to refer to the chain where you're sending funds, or the chain where you're taking funds. And we have it here as the destination chain ID, for example, which would be using the EIP 155 chain IDs, but that's not really sufficient in, when we want to have a wider reach. Like just as one example, Starknet doesn't have a chain ID, and they're a good friendly rollup that we want to be able to have intents to and from. And they wouldn't be supported here. And also addresses, here they're represented as a bytes 32, but that's not a standardized format in any way. Like, and in some cases, an address may not even fit in bytes 32, and you want to be able to support that. But again, having this be standardized is super important for this coordination property that the standard requires. And so, this was another problem that we had. And the final one here is that there were some parts of the interface that were under-specified, like this filler data over there. It's just like a bytes parameter, and then the filler has nowhere to see, okay, how do I even provide this value? It's the thing that's usually used to like put the address where the filler wants to receive funds, but some protocol might want some other thing, and there nowhere in this interface says how to actually do that. So these were most of the problems that we saw. And that's what motivated us going towards a kind of an iteration of the ERC that we are calling V1. So to introduce the direction that we have taken with V1, I want to highlight first, the one thing that I think was a really good idea that V0 introduced is this resolve function and the resolved cross-chain order, whose role is, as you might see, it has no protocol-specific order data in it, and it attempts to be this comprehensive description of what the order is in an actually common standard language. And I think that was a really good idea that we took, and we even sort of furthered in the V1 that we are doing. So the way that resolution works is that the filler is now going to be receiving from the feed protocol-specific orders, but in some standardized sort of packet format that the ERC defines, and they, but they're going to be encoded in some opaque way that the filler won't really understand as is. But we introduced this role of the resolver. And the resolver provides a service of like taking these protocol-specific payloads and translating them to this common language that is standardized by the ERC that we're calling the resolved order. So when they receive it before doing the fill, they go through this resolution process, and that can tell them exactly, what the order entails and what steps to follow. So that is sort of the transition that we are making, and so the challenge then becomes, okay, how do we specify this resolver? It's got like a very difficult task of representing very wide, a wide variety of protocols and orders that they can implement. So the philosophy that we have taken with this redesign, which is essentially what it is, a redesign, almost from the ground up, except for this one bit of the resolver, is to try to use, as much as possible, these general purpose building blocks. So this is in contrast to what we saw before about this order data thing. That would be non-general purpose. And what we want here is to have like very general purpose things that can be used across protocols so that the implementation of those things in the filler can be reused and doesn't have to be re-implemented. So what we have done is taken the notion of an order and try to pin down what exactly does an order consists of. And we have reduced it to these four things that you see here in the resolved order struct. An order in an intent protocol will imply that the filler has to take a certain series of steps, right? And the steps will be transactions. You can think of it in that way. And the transactions might be that I take a signature from the user and I submit it to a contract to pull the funds in. I then go to the destination chain and I send the fill transaction to provide the funds. Then I go back to the origin chain and send another transaction to claim my funds, right? So those would be like 3 steps that a protocol might require from a filler. And that would be modeled in the steps part. So let me take one small step back and explain like who writes this resolver, where is it, so the resolver is, as I show here, is an interface for a contract. This would be a contract that lives in what is often called the periphery of a protocol. So say that Uniswap develops a new intent protocol, they would, along with it, develop a resolver, a compliant resolver, and deploy it on-chain, even though it only has a view function. And you will obtain then the address of the resolver. And they would implement it in a way that understands Uniswap's new intent protocol and is able to translate it into these generic representations, right? So this is a periphery contract again that would be used by the filler in this step that we showed before, right? So the resolver here is a contract on-chain. So it takes the protocol-specific order and it translates it into this format. Like I said, the first thing that's very important is, okay, what are the steps that the filler has to follow? The other important component of an order that we've identified is what we call here variables, and these are some choices that the filler has to make. And that eventually would become like pieces of data that have to be injected in these transactions that have to be submitted on chain. And by choices, I mean things from very simple things like what is the address where I want to receive the funds, to potentially more complex things like how do I participate in this auction? So to give an example of that, some intent protocols nowadays, including LeFi that we are collaborating with, are using Dutch auctions to do parts of the intent flow. And when a filler has to participate in a Dutch auction, they have to decide based on sort of the pricing function, at what point in time are they going to go ahead and fill the user's intent, and what price are they going to give to them. So it's kind of crazy, right? Because this is a very complex thing, but it's quite cool that I think we have actually achieved to represent it in this generic way, which is the timestamp at which you send the transaction is a variable that the filler has to choose, and it's sort of injected in one of the steps as an attribute of the transaction that has to be sent, and that gives the filler all of the information that they need. So as I now move on to talk about assumptions, this last thing that I just said is very important. The goal here that we have is to take all of the information that is relevant about an order for a filler to know, and to put it in here in these general purpose building blocks that we're trying. So the next one is the assumptions, and this is kind of a trust assumptions kind of thing. The truth is that ideally you would only sort of trust the intent protocol that you are interacting with, but sometimes there are pieces where there's, say, you call a contract that the user provides, right, to implement some sort of callback handler, and the protocol requires that doesn't revert. And if the callback does revert, then you're sort of reverting the entire fill, and that may leave the filler at a loss. So there are these points, and it's not just something we've made up, it's actually something we observe in actually live protocols. You have to make sure that the callback that the user has provided will not revert. So we have to take this and represent it somehow, and we put it there in this assumptions field. And lastly, the payments field is the proceeds part of the order, so it's what the filler will receive. One note that's very important, as you will see here, there are a lot of bytes in this ERC, a lot of bytes types, but in contrast to V0, each of these bytes actually has a very specific format that has to be followed, and with a very specific semantics that the filler will assume. Let me think about what am I missing. Yeah, so we have solved here the problem about only approximating the cost and the proceeds. The way what we have defined here allows us to do that very accurately, and even to support these kinds of pricing functions where it's not just a constant number of funds that you would receive, but that depends on the choice that you make. So we support auctions, like I said, and we also support resource locks, right? So not only escrow-centric like the version that we had before. Yes, so I am missing one thing that's very important to understand, which is, our goal here is to reduce the effort that is required from the filler to integrate with a new protocol, right? This was like our goal, the thing that we are after, but it's not really possible to completely eliminate that, because you at least have to know that the protocol isn't going to rug you, right? So the thing that we reduce this to is just a whitelist, right? And that is the goal. It is that the filler operator would be able to configure their filler software to say, yeah, I trust this protocol at this address, and I trust this resolver at this address to tell me what steps to follow, how to participate in the auction, and so on. And so that would be the only integration step required from the filler. And it's a little bit difficult because you do have to understand the protocol, but it's something that you can look into audits that professional companies have done. You can look at TVL and you can look at sort of ecosystem adoption. So filling a whitelist of protocols that you support is a lot easier and a lot lower barrier than writing up the whole filler software like we sort of had before. So this is just a little taste of what one of these resolvers looks like. Admittedly, it's not easy because it's doing a lot, but this is a part of the prototype that we built last week in this sort of build-a-thon that we ran with some community members. And so here what we see is one of these steps, right? Is the step to call the fill function that we see at the very bottom, and we're saying what is the contract that we have to hit, what is the function that we have to call, all of the arguments that have to be provided, and these attributes that I mentioned before, right? Like, this is a call that you can only make before the fill deadline. And this is all of the information about this step that is relevant for the filler. So yeah, that was the overview that I wanted to give. This is really just kind of like an overview then of what this filler, what sort of the rightmost part of the life cycle would look like, or actually all of it, which is, you go from an intent to a protocol-specific order, you then encode this in this compliant packet, which consists of this payload and a resolver, right? And then you give that to a filler. And then going through the resolver, the filler can get a resolved order, which has all of the structural information needed to then go ahead and do the fill for the user.
Okay, thank you, Fran. So now that we know what OIF is, what's going to happen with OIF in the future? And it's something that we're still looking into how to solve, but there is a classical problem that we want to avoid, and is that this is a standard that is trying to substitute other standards. So there is a possibility of us running into okay, this is just another standard. The way we want to avoid this is by building along the people that actually use the applications, that actually build the protocols, that build the wallets, and that build everything around it, so that at least this is a recognized open source, fully modular standard. We understand businesses will try to come up with their particularities, and they will have their own nitpicks, and they may have their own APIs. But this is intended to be a fully open, available for everyone standard that everyone can use. And the way to get there is to expand and build together. We want to onboard new layer 2s. We want to make sure that the experience from getting to 0 to 1 is as good as possible. We want to make sure that the solver and the aggregator meet the demand from the protocol operators, the networks, and the community. We want to make sure, we want to facilitate existing protocols and existing wallets to be compatible with these APIs. And we are obviously open for all protocol operators and standards to come and build with us. And once we have these basic blocks with more oracles, with more wallets, with more things, then that vision that we talked about at the beginning of any new wallet being able to integrate this standard and connect to multiple solver networks, to multiple protocols at the same time, is going to become a reality. So now it's time for the demo. I actually had this fake quote prepared before, but it's now more true than ever, because as you've probably been suffering, the internet in the event has not been the best. So we're going to give it a try. We are going to take a look at a reference UI that we've built for demo purposes. So this is like testing UI that we've built inside the OpenZeppelin team. It was first intended to like test internally how. Let me make it a little bit bigger. It was intended to understand and facilitate testing of the APIs, testing of everything, but we've realized that it's also a very powerful tool to show to people the power of these things. So this UI basically allows you to swap between tokens on different networks. Right now it's connected to 2 different solvers. Each one of those solvers have, and now it's where the demo may fail because internet is working, awesome. So we have 2 different solvers. One is our mainnet and one is our testnet solver. The testnet solver, we can go here and see like the assets and networks that it supports, and same for the mainnet one. The idea, or the reason why we have a mainnet solver is not to test with real funds, because the tokens that we have in here and we have supported are fake USDC. It's more to ensure that people and protocols can build and test with real oracles, real RPCs, and the real building blocks that they will be actively using. So there is, like for me, there is a cool thing about the OIF and about the internet protocol that we've built, is that when you want to, for instance, pay for a coffee, the coffee will cost you $2, whatever amount of thousands of Argentinian dollars that is. But you will like actually have to think, okay, $2 plus gas fees, plus the solver fees, plus other things, I have to send like 2.35. And then the guy in the coffee shop will not receive $2, will receive like 1.99999. So something that it was very important for this protocol is to be able to have an exact output number. So let's give it a try. Let's see if internet behaves. I'm going to do a transfer of 1 USDC from Optimist Sepolia to Base Sepolia. Once I input my information, I can request for quotes. This is connecting to the aggregator that is deployed live. By the way, you can go to the URL above. I will show a QR in just a second. Bear in mind, this is testnet infrastructure. It's intended to like be used, but you may encounter some hiccups. So the aggregator has now filtered, based on the tokens and networks that I have selected, which solver is able to give me a quote. In this case, it's just the testnet solver, because I selected testnet networks. Each solver will give you a quote with a deadline. A deadline because maybe, well, in this case, USDC is relatively stable, but maybe you are moving from Ethereum to Bitcoin, and the volatility in there may be higher, so the solver will give you just a quote for like a minute, for instance, which is more than enough for normal use cases, but in this case, I've been speaking for more than a minute, so this quote is outdated, so I'm going to go ahead and refresh. The quote is the same because it's the same. Once I select this quote, it's going to give me a lot of information about what is going to happen. It's going to give me the solver that is going to be doing the field, quote ID for reference, the information about the inputs and the outputs, and then I'm going to be able to, in here, sign the intent and propagate it and send it to the solver. When we think about how to integrate the OIF, all of these will be built into the app. So, for instance, in here, you can override the private key that is going to sign the intent for testing purposes, but in reality, it's going to be just built into the app. Just for preventing problems, I'm going to refresh quotes again and go ahead with it. So I'm going to sign. I'm going to sign the intent, and I'm going to submit it. Once I submit it through the aggregator, it's going to go through the full process. Hopefully internet stands and doesn't get stuck in the middle, but basically what this is doing is getting my funds transferred into the input settler via, in this case, it's a direct escrow. The solver is picking this up, and it's going to fill the intent. After the intent is filled, the oracle will pass along the message to the primary network, and the solver will be able to claim their tokens. So while, in this case, the oracle is doing things, we can go to, this was OP Sepolia scan. And we can see this initial transaction that does not exist. Okay, maybe it's in base Sepolia. There we go. So we can see this USDC was fully transferred. So the oracle, different oracles will take different times. The oracle will propagate the information, and the solver will be able to claim this back in the source chain. It's very important to choose the proper oracle, not only for the time that it takes the solver to get the money back, but also for the trust assumptions. And we have seen this will become one of the main areas where OIF will need to be modularized and executed. This may take a while, so let's go back to the presentation. This demo.
I just want to make something clear, which is at that point, the user's funds were already delivered,
Yes.
right?
Yes. The user, the speed of the intent is super fast. So the user doesn't have to wait for an oracle. The user has the money. The actual intent takes whatever amount of time the solver thinks is safe for them to assume that the funds are properly escrowed. So if it is a higher volume, the solver may want to take proper finality time on Ethereum. If it is more day-to-day activities, it may be okay with a couple of blocks of confirmation. So you can all access this demo on oif.openzeppelin.com. Give it a try. You can freely mint all the tokens supported there. So, the solver doesn't have a lot of millions of liquidity, but feel free to mint, give it a try, and move funds around. Oops, sorry. We've also built this for the community. The open intent framework is supposed to be open. So there is a lot of documentation that we've put together at docs.openintents.xyz. And we also have everything in the openintents.org in GitHub. I encourage everyone to actually take a look, reach out to us if you are building things, get interested if you are integrating a wallet, or you have a solver, or you have a network. Reach out to us, and we will be super happy to support on that. So thank you very much. We have 10 minutes. We've started a bit late, but we have a couple of minutes for questions. So if anyone does have any questions, I assume someone will be able to pass them a microphone.
Any questions?
Any questions? Yeah, can anyone pass a microphone to him?
Hi. We've actually built a testnet app, which was a fork of privacy pools, and then open intents coming in and out. But one of the things we realized is we had to, the create order interface of the open intent, in order to provide that compliance layer of the associated set provider. We modified it to also prove that this address created the intent. So there's an extra dual oracle. And because we've modified it now, we can't just plug into the default solvers. They're going to have to be aware of that extra step. Am I talking about this correct? Okay, so I guess we want a hackathon, but I'm wondering you're probably the right person to talk to in terms of how do we, because it's hard building on intents, right? It's not like before where you just build a contract, point it to an RPC, deploy it, and yay, it's a lot more complicated. So I guess I'm kind of here to find out what the next step is in terms of how do we connect to people running these solvers, how do we tell them about our modified order interface, and did we even do it in the right way, I guess. I'm really looking for feedback on that.
So I think there is two parts to it. The first one is how do you reach out to like existing solver networks, and the OIF at the end is a framework, and we run like a demo solver, but the reality is that the real solvers with real liquidity will be needed to like, okay, talk to me, modify this, and all of that. Right now, the biggest solvers networks that we are talking with are LiFi and Across. We can get you in touch, but like the reason why OIF exists is because very likely LiFi and Across will tell you like, come back to us when you have a couple of millions in liquidity. So the cool thing about OIF is that you can go, take a look at the solver code, ask someone with Rust experience to like take a look. It's very easy. We on the hackathon that Fran mentioned earlier, we got people running their own solvers, modifying their own solvers within a couple of days. So you will have to adapt to it. There is a second part to that, that is the 7683. So if you are able to like fully standardize and modularize the steps that your intent requires in a 7683 compatible system, the solvers following that will hopefully be easier to integrate. So I'm not sure, Fran, if you want to kind of expand on that or like.
No, yeah. I mean, the first point is like, I'm not sure if I mentioned this, but this new version of the ERC that I described, I would say it's kind of like in final research stages, so not deployed yet. But if I understand correctly, you edited the contracts. The contracts, right? So that's like I think a perfect use case for, you want to tell fillers what they have to do to fill this. And in that case, once we have this, what you would do is you implement a resolver or you fork a resolver to properly work with this new field that you have and construct whatever data you need and so on. So I think it's a perfect use case. And yeah, I would love to know a little more and understand if it does work for it.
Perfect. Any more questions from anyone?
Hey, thanks for the presentation. I was curious, how's wallet adoption around this? Like from what I saw on the demo, and sorry, I'm a bit of a beginner around the intents. Like it's a standard like 712 signature. I'm curious if there is work on wallets to adopt the standard and make it more clear to the user what's the intent they're actually signing.
Yeah, there is. So there's two parts to that. First, there's wallets actively collaborating with us on like supporting OIF API, especially because LiFi being one of the biggest contributors to this, there is a lot of wallets connecting to them. The Wonderland team also are working on wallet integrations, and they are part of the OIF. There is also a standard that I don't remember the name about kind of facilitating clear signing of 712 data, and OIF relies a lot on that. So it's still going to be encoded. It's still going to be a layer of decoding that, based on current expectations, is likely going to live in an SDK, because when building the API, we had to decide, okay, do you trust the metadata that the solver is sending to you, and then you construct the encoded version and then set it on chain, or vice versa? So we went for the solver sending you the encoded with an extra metadata field that is like, it must be used just as a helper, but if you want real trust assumptions, you need to decode it. So the first steps are being done to like facilitate this wallet integration. There is an ongoing work on SDK that will like actually be able to allow wallets to decode the data and fully like trust the data they are showing. Okay, so unless there is any more questions, again, thank you very much for being here. Any questions? Happy to chat around. Thank you very much.
Thank you all.
execution that can be involved with multi-steps, with actions. We're going to talk about actions in a minute. And batch mean an executions that can end up or start with the voucher. Voucher is the element that in charge for transferring funds between different chains. Creating a voucher means depositing funds into a contract that later will be claimed by the same signature on a different chain. And on that case, you actually get the bridging transfers from one chain to another. What else we have on the concept stage? Beside actions and batches, there is a multi-chain concept. Since we're dealing for the first time properly in code with multiple chain, the idea is to create in code entities that will be involved with more than one chain. In that case, a contract should be handle should be aware of different chains and to handle multiple addresses in case this exact same contract is available on more than one chain. So let's go a bit about this stuff, just like to get you what we have, and about the plan for today. So first, the idea is to show how easy it is to have a new protocol involved in any system that based on EIL. In that case, we're going to get a couple of elements in order to make it happen. First, as I mentioned, actions are basically the building block of execution on EIL. The SDK, the EIL SDK already provided some of those. A basic action to call contract, an action to call ERC20 approval, transfer, native token transfer, and so on. But this is like very few of what can be done. What we did actually, part of this demonstration, but also of building Stitch that Ivo going to show in a couple of minutes, is we build a logic that involved with multiple chain and multiple protocols. So in that case, the architecture that we had is to have each execution or each step that we want to have that relates to a DeFi protocol as an action. And on that case, once you have action for deposit, withdrawal, stake, wrap, unwrap, and so on, you can later make a logic that involve with them and make the great experience that we have in with EIL that involve with multiple chains, multi-step, but with a single signature. And so we're gonna see how I'm gonna create an action, okay? But for that, this action, by the way, will be add liquidity to Uniswap, okay? An action that involve with two actually different tokens, and calling the Uniswap router, okay? Before that, we're gonna create the entity of Uniswap router and anything that relates to that, okay? And of course, at the end, we're gonna see it running with an example of USDC from Arbitrum and USDT from Base, navigated into Ethereum, and then executed as a add liquidity call to Uniswap, and in between we're gonna get ERC20 approval for both that is required for the third action. Okay, down to code. So we're gonna see, so let's open, and I'm gonna show around what we have. Okay, fine, so maybe I'll put it a bit more larger. So what we're gonna have. So first, this is what already implemented. You can see the following protocols already supported. We have Morpho and Limitless and Lido and Eigenlayer and BFI and Aave and so on and so forth. And we can see that each one of them, if you check Aave, for example, it's involved with all the elements that I just mentioned. We're going to create the same for Uniswap liquidity pool deposit. So let's start first. So as I said, we're going to have an action, but before the action, we need to have a contract. Factor is right now unrelated, but I want to have a contract. In that case, I already predefined the addresses of the Uniswap router, okay? Per chain. Address per chain is actually an entity that already, a type already provided by the EIL SDK. And once I defined each one of those, we can check, for example, that this one on Ethereum is already here. Okay. So we have the contract address, we mapped per chain, and then next we're going to create the router ABI. Already set it up, but as easy as it sounds, it's about going to the, we can use the Etherscan, go to the ABI, just copy it, put it over here, and this is considered done. So we have the ABI set, and we have the addresses, as you saw already, set. And now we're going to create a multi-chain Uniswap router, okay? Luckily, we have AI here involved, so once I'm doing export, class, you already recognize that this is what is required. And you can see that we basically inherit from multi-chain contract, okay? That is a class involved with that actually represent a contract in EIL SDK. What is expecting as parameters for the constructor is the client, because we want to execute through this contract. It also requires the ABI, as we already defined, okay? And it also requires the addresses map that we saw in advance. Side comment, we don't necessarily need to have all chains supported. It's enough to have one. One is actually a bit irrelevant, but more than one is probably will demonstrate the case that we are having or talking about multi-chains. So, and later we will see that if we need to use this kind of contract, we need to validate that this contract supports this specific chain. So, we have a router. So in this case, this router can be used in order to fetch the contract, to execute, to use it for any other type of execution that involved with this router. So once this is done, the next step will be to create an action. So you know that we're gonna have, we're gonna go for add liquidity, right? And as you can see, add liquidity has a lot of parameters. So I'm gonna skip that, like doing this like manually. I'm gonna check it out over here and show around that how it's look like, how the action should look like. So we see that it's inherit from base action. Base action means an interface that eventually have an encode call that will get you the encoded call data to be executed. So, and it can be like also a map of call data. But in our case, once we want to have such an implementation, then we'll see that we need to fetch first all the parameters that we need, okay, on the constructor. That means the router, of course, the receiver address, okay, token A, token B, amount desired for A and B, if needed, min A and min B, that is part of the add liquidity call, and a deadline. In that case, once we have it, the encode calls actually means to format this as an encoded call object and get the exact execution on its way. Of course, args will be the same order as we know from the contract itself. Function name, very straightforward, and it actually supports VM SDK as we know. So that should be like super transparent to any Web3 developer, and should have it to use, ready to use very simply. So again, back to what we had. We had a multi-chain Uniswap router defined. We had the Uniswap liquidity action in place. That means get me the parameters, and from that point, I know how to encode an EVM standard call. And once we have that, now we can use it and make this thing function. I pre-created a test for it that will be in a way gonna take us, as I mentioned, through the entire journey cross-chain from USDC from Arbitrum and USDT from Base to Ethereum, and then deposit or add liquidity into Uniswap. So basically, putting such execution in place should again be something that is very straightforward to who is involved in the blockchain space. We create a builder that is the most fundamental element on EIL execution that is already there. And of course an account that represents the user account. Later Ivo will show us how it looks on the UI and how Ember Wallet implemented that for the users. And the parameters that we want to have, amount desired, and for token A, token B, deadline, as we saw parameters. This is for test reasons. We're going to fetch balances before we do the execution and after and see the balance change. And now we're going to see the creation of a batch. Remember, a batch represents an execution on a specific chain and can be involved with creation of a voucher. So here we can see a create batch that is only involved with add voucher request. Add voucher request is an action. We learned that the actions are actually the steps of execution on EIL SDK. So what we actually saying over here is that create a voucher of USDT token with the desired amount means that I wanna take out of Arbitrum USDT on this specific amount. And later we're gonna see also a batch that someone will claim it. Sorry, we're gonna do the same for Base and USDT, creating a voucher, a batch that involved with only a single step of creating a voucher for USDT on Base. And on that case, what we will see is that we're gonna see funds moving out of Arbitrum, USDT actually, and USDC from Arbitrum, and USDT from Base, and USDT from Base. And what is missing will be the next step where we use all voucher. This is the Ethereum mainnet batch creation. And we're gonna see, on that case, use all voucher means claim or get all the funds that were involved in the voucher creation on the other chains. And we're gonna see the funds moving into this chain, and then we can use it. The next step for us will be an add action for approving USDC, part of the requirements for liquidity addition. Yes, it's actually having the before that an approval for the two tokens that involved in this action. So we have an approval action for USDC with the relevant amount, and we're gonna have approval action with USDT for the approval amount. In this case, we put max value, but definitely it should be set as like specifically what we want to have on this execution. And the last one of this action is Uniswap add liquidity action that we just created with all the parameters that we mentioned before, Uniswap router, account addresses, USDC, USDT as token A and token B, amount desired, min amount for both, and a deadline. We're going to execute that and see the balance change accordingly. Now, since we have a lot of connectivity issues, we're going to hope for the best and see that running. And I hope I didn't forget anything. Yes, of course I did. And second. Okay, we have that in place. Now let's run it, make sure that it's functioning. Hope network will be on our side. No, it's not. It's actually failed for timeout. Anyway, we had all predefined some action that I already ran it before, like an hour ago, when I have like optimal connectivity. So I'm going to show that instead. And first, this is we part of the project of building Stitch and also involved with DeFi implementation for EAL, an extension. We created an explorer that involved with all chains supported. So in this case, we can see that we have the Ethereum mainnet actions that are 3 of them. We see the approve, 2 approvals, and the last one is add liquidity. We see on base actually none, just the voucher creation, and the same goes for Arbitrum, that is a voucher creation and approval for probably the related stuff. And now if we want to check how the execution look like, we can take this this user op. Where the TX hash. Okay. You can take this TX hash. Before this, we built the entire environment, 4 chains on Tenderly VNets that will be also used for the hackathon, the EIL project on the hackathon, on the ETH Global Hackathon. So we have it already. And on that case, we can see an execution on Ethereum, and we can check for this specific handle op, user op, and of course, okay, we got it. So let's shortly review what we have. We can see that, I don't know if it's like visible enough, but we can see that we have, of course, since it's account abstraction based, we see the entry point and we see the cross-chain paymaster and all of that. But we can see also that the null address, this line, is actually involved with issuing liquidity tokens of Uniswap. If we go to Etherscan and put this one over here, so you can see that Uniswap V2 ERC20 token pool is created and transferred into the user. This is the user address. The user also got on Ethereum a bit of USDC. That's because when you deposit into a pair, it will take the exact up-to-date balance, and if there are leftovers, they're just going to remain on the account wallet. On this case, we have 4, and we see that only 3.005 got into the wallet. So in that case, we had 4. Some remains on the user wallet, and some got into the Uniswap V2 pair. What else? We can go to dev mode and see like the exact execution, but I will skip that stage, that step, and can have this like ignored for now. But as you can see, we see that what happens on Ethereum, on the destination chain that is Ethereum, is actually exactly what we need. We had the transfers appears from the cross-chain paymaster. We see that the deposit made into Uniswap V2 pair, and the same amount that we defined. And on that case, it's actually exactly what we want to have. So that's kind of it for us. That means, back to this, we managed to create exactly a multi-step involved with more than 5 actions into this, made it exactly the way we want to, and it's a matter of a couple of minutes. Of course, I know this is like I did it in advance, so it's easier for me, but imagine that it's involved with any basic fundamental smart contract wallet involvement. Now, Ivo going to show us what we build with Stitch, and going to take us through the impact of this on user experience with Ember Wallet.
Sure. So this is Stitch, the app that Ophir implemented, and it's the first app to really use the Ethereum interoperability layer. And I'm from Ambire. I'm going to show you how it integrates with Ambire, which is the first wallet that implements the Ethereum interoperability layer, and the impact for users. So the cool thing about Stitch is that you can use balances across any number of chains without really caring about where this balance is. So it's essentially balance consolidation. So the impact of this is that neither in your wallet nor in the DApp you're going to see fragmented balances anymore. So if you have USDC on 5 different chains, it's going to appear just like one USDC. And you can see a perfect demo of this over here where balances are consolidated by network. We have this very cool feature that we can actually peek into the underlying distribution of balances. So we can see that we have like a ton of different wrap tethers, ton of different USDCs, and etc. And by default, if I just use USDC from here, Stitch will decide, or the Ethereum interoperability SDK actually will decide automatically where to use the balance from. But just for the sake of the demo, I'm gonna either like use all of the balance, ensuring that it hits all 3 chains, or I'm gonna pick them manually. To show you like essentially the future, what I'm gonna do is I'm gonna allow it to pick automatically. So I'm gonna enter 22. I have 10 on 3 different chains, so 22 must hit 3 chains. So yeah, it must use consolidation. Then on the output, the cool thing about Stitch is that Ophir already showed you all the protocols it implements, and I can plug into any of those protocols. So I can say, put my 22 USDC into Aave, let's say. Now it's loading a quote, and if the internet is good enough, we should get it working. And yeah, and this is essentially a preview. The user doesn't need to care about this, but each one of those arrows is a separate 4337 user op. And we have some voucher usage here as well in order to consolidate those balances into Ethereum. You can see that we essentially use USDC from 3 different chains. I know it might be a bit tough to follow, but what happens here is we take some from Optimism, we take some from Arbitrum, we put into Ethereum, and then we put them into Aave. So now when we click submit, this is going to start loading a request to Ambire Wallet to authorize all of the user operations at the same time. It's going to take a while, again, because of the connection. But hopefully, what we're going to see here is a dialog from Ambire Wallet showing you to authorize all 3 user operations at the same time. And at the moment, it just shows hashes, but clear signing is coming, and this is going to show you, oh yeah, it's working. This is going to show you exactly what you're signing in the future. So it's going to tell you exactly what you're authorizing with a simulation as well. So it's not going to look like this. But then when we click sign, this starts working, and essentially all of the user operations get broadcast using the respective bundler on each network. Gas is paid only once, even though we're doing connection across 3 different networks. And hopefully, if we get this confirmed, we're going to show the EIL Explorer. Yes, we have a link, go to Explorer, and when this loads, you're going to see all of those operations across all of the different networks that we just interacted with. So yeah, here we have a preview, the same schematic that we saw, and we have the raw code data on Ethereum, the raw code data on Optimism, and I think we had one more chain involved. Yes, Optimism. And yeah, we can see each individual user op and how it translated to an individual transaction. And obviously we can check this in Etherscan if we want, or Arbitrum scan, or whatever. So yeah, that's pretty much it. It feels like magic. It's pretty fantastic. Back to you, Ophir.
Thank you. Cool. I guess we pretty much covered anything. Probably gonna go to questions, if there are any.
One over there.
Yes. Gonna put this. Yes, please.
Am I audible?
Yeah, you are.
Okay. So on your example, I see that you are trying to move $22 worth of USDC, and you are putting it into Aave. Am I understanding that right?
Again, 22 USDC, and to put it where? Into Aave, yeah.
yeah. So I see that there is only $12 is the so 10 plus 2 makes it 12. So another $10 worth of USDC is taken from Ethereum chain itself.
Yes, the idea is we have 30. And in that case, we're going to have 10 each. That's the original state. So what we did over here is to translate, to actually transfer 10 from Optimism and 2 from Arbitrum into Ethereum. And then you got the rest of it moving from, it's actually 30 on that case, and move all of it into it's actually, no, it took already 20, just 22, but it took it from Arbitrum and Optimism, okay? So it's actually not involved with the funds that were in other places. Does that answer your question?
Okay, but I think my understanding was that you are using.
By the way, I'm assuming the amount could have been a bit confusing. So essentially, you had 10 in one chain, 10 in another chain, and 10 in a third chain. And I showed 22 in order to show a real-world scenario because 30 is like too perfect. Because 22 requires taking 2 just from one chain in order to be able to get that amount. Because if it was 20, then it would hit 2 chains. Anything more than 20 hits 3 chains because we had 10 in each individual of the 3 chains. So I wanted to show a real-world example of how consolidation will work.
Maybe you want to have the mic from him.
Even if he has the mic, I don't have the
Okay,
headset,
okay.
but it's fine.
I was thinking, how does the chain that like, is there a preference of like we're gonna take 10, 10, and then because like you could have taken 2 from Optimism and 10 from Arbitrum. How does that happen? Like alphabetical order in the list of?
I'm personally not familiar, but
I will explain. This is like
yeah.
EAL, and that's something that can be a bit confusing. EAL is not like an intent solution. It's not building the logic for you. It's actually providing the infra to navigate funds and do this all beautiful one single transaction multi-chain execution. What we build on top of it is to extend the building blocks into more DeFi protocols, and you can see that over here. So you can see all the chains that we already supporting, and actually all the DeFi protocols. But the logic is actually built on top of EAL, us saying that if you have funds on a specific chain, maybe it's better to use it in order to save the gas, or you can define specifically what chain you want to use. So the logic itself built on top of it, I won't say that important it's just like a way for us to demo. What is important is that it's the infra, the EIL SDK makes it super easy to build something like that and let you focus on your exact logic or the use case that you want to support, and not dealing with gas and cross-chain and failures and multi-signatures that are not available like mostly on any other case, and so on, so on, so on. So the idea is that you can build this logic like more properly.
So what I was going to say is that because I've been thinking about this from a wallet perspective and how to best consolidate it, obviously you want to start working from the destination chain. So if you have funds on the destination chain, not complicated.
Are the docs going to be up in time for the ETH Global Hackathon on the repos, or we really got to dive deep and figure it out?
So
can you repeat the question?
The question talks about the documents of EIL. So it's already here. It's already published. It's this morning. What is missing? Probably like a Tendel integration that we're going to have because we build for you up-to-date environment running, but we're also going to have an additional documentation of how to run your environment, your Tendel environment, and play with that. So it's mostly there. I guess it's probably not perfect because it just launched, but we're going to be there anyhow, and we plan to have tomorrow a session of explaining how to work with that and what can be done with this and capabilities and what is supported and so on. So make sure to be there, and you're probably going to get all answers to any question.
Perfect. And one final question about the stitch, and I kind of asked this yesterday, and the answer got cut off and sideways, but I guess I was thinking, like, how does the EIL be aware of, like, the current value of all of these things and, like, the quoting or, like, getting the best price from the wallet standpoint? You have to use something else to do that. Like, can you give me an example of, like, is that Xerion? Like, just help me, give me the,
Yes, for sure.
the stack.
So he's asking about like the data like Stitch is using. And I'll answer that because like probably more relevant. You can see, I guess it's like now very common to have to split on any Web3 related app, DApp execution, to actually split read and write. If we are treating blockchain as a database, read and write are separate. So in that case, you mostly deal with one of them. In that case, saying that because EIL is actually for execution. You won't see here any code or like balance between Uniswap pools and so on, because the idea is to deal with execution. Single signature, as I said, having the ability to support easily any protocol, having like the best experience and so on. Fetching can be done like in any way that you can imagine. In that case, we use like very common data providers, like in that case it was Alchemy and so on. So it's mostly getting the data as you can. There are some like on Stitch, we tried as much as we can to base our data on on-chain data. So it's I'm saying like as a service, Alchemy and so on, but for us, the ideal is to get the data on-chain, but in some cases you cannot do that, okay? Problems start, by the way, or when you can miss stuff is when you get all kind of protocols that are not really on-chain, okay? You see, for example, I'll show you something. You see, for example, that we do support limitless. So you can see any scene or any market, I don't know how they define it, on limitless is supported. But now limitless moved to work on a different mode when you talk with their service and not directly with the smart contract. On that case, we have with EIL, there's no value with that, and that's very obvious. So it's kind of unrelated to that. So in this example, you can see that we only support the on-chain element that involved with the limitless.
That's perfect. And one final question: the EIL Explorer URL. I'm explorer.syndica. Is it?
Yeah, I will share it also. This one, I will share it on the commentation. This is like something Syndica voluntarily did in order to support this project, because we want to have some kind of an explorer that involved with multiple chains and batch execution, or like present execution that kind of unrelated. The connection between the batches or the transactions, user op and so on, is not really on-chain. So you cannot match or connect them like properly. So we built some basic UI just to get it in place. I'm going to share it too. It's going to be available. It's very basic. We're going to extend that into something like more fancy, having the ability to define the transaction of voucher creation or voucher usage and so on. But for now, I guess it's a good start to direct you into the real Explorer and so on. So, cool.
Hi there. I maybe not directly related to EIL, but I'm having trouble understanding the relationship between EIL and OIF. It seems
cool.
EIL is at the bottom of the stack, provides a very simple intent solution, and more complex intent-based solutions are in OIF. Is that correct?
So I'll tell you my point of view about it, because that was mentioned also yesterday when we introduced EIL for the first time. Your confusion is actually coming from EIL ability to support intent solution very easily. So since it makes it super easy, it's put you in a position that it's a bit confusing. There's like not much more to do in order to get you an intent solution. Actually, Stitch is an intent solution. You're saying you want to go from here to there. There's like many to many, and the magic happen. And it's built with the UI only, like a logic that runs on a Chrome extension. In that case, EAL is actually the rails for it. It's actually the highway that you want to go through, and all the apps are the cars that riding through that highway. Intent is only one of them. Okay, I guess that's like the definition for it, but it makes it easy for building such solution. I guess that's like the bottom line and the most important message that can be provided here.
Got it. So I want to add something about this, pretty much kind of the same perspective. They're complementary. By the way, everyone is asking about this, so it's good to clarify, but there is no simple way to clarify without understanding each system in detail. But the thing is, EIL doesn't remove the need for intents, although in practice, because it's this multi-chain execution layer, first of all, and second of all, because it provides a way to move funds across chains, those two things combined lead to intents being less necessary and a classic like third-party solver being less necessary. So in a lot of ways, the wallet can become the solver or the dApp can become the solver, and EIL gives you better primitives to do that. Because if you don't have the primitive for multi-chain execution, then it's really easy to shift this to an intent engine and a third-party solver and to just rely on this solution. But one example is if I want to bridge funds to another chain, then on the other chain buy an NFT and then send the NFT to someone else. Those are three separate actions. And nowadays, if I want to do those three separate actions with just one signature, then the best way to do this would be to depend on some bridge which has post-operation hooks. And this bridge is definitely not completely trustless because it has to execute some code on behalf of me on the destination chain. Even if I authorize this code, it does have some trust assumptions. And with the EIL, the ability to execute those operations on multiple chains with the same signature removes that dependence on this third-party bridge. And also the ability to move funds between chains with the voucher model also eliminates this need. So in many ways, it eliminates the need for a classic intent system, but in many ways also you can think that first of all, the wallet becomes the solver, the dApp becomes the solver, and finally some elements of the interoperability layer are intents in themselves. Like the cross-chain paymaster is kind of an intents-like system. The voucher is also kind of an intents-like system. So yeah, it's really hard to explain, but they're complementary.
Got it. Okay.
Great. I guess we are done. Thank you, everybody.
Thank you.
That's no problem. No problem. No problem.
So when you're on this slide, like just click on the video, so that should start playing.
Okay. Well, you standing next to me, so we can just butt in.
Oh yeah, you stand here.
Yes. Thank you. Good afternoon, everyone. Thank you for being here. And today, why we should care. First of all, the usability. EOS get a new lease of life so that you can have one-click action transactions from 7702 through bundling. What else? Well, you can get advantage of using Paymaster, meaning your users can use a stable coin to pay for gas, or they can use any ERC20 token. In fact, if you have a subscription fee model, you can use sponsored transactions and your users don't even need to know about using about gas payments. Okay, but lately we have seen the whole ecosystem tending towards using centralized services. I'll tell you what I mean by that. Think of the Cloudflare issue yesterday, how many Web3 services were affected. Or in fact, think of AWS outage recently and how many Web3 services were affected. So you can take this further and imagine there was a 2008 style run on the bank, and with all DeFi infrastructure being heavily exposed to dollar-denominated stablecoins, what would happen if any one of them, if there was that run on the bank? I would let you guys ponder about that. So with the centralization issue, another issue we have to think of is with the recent hack of, what was the name of, is it the hack? Okay, the recent hack of a DeFi protocol we've seen quite a lot of centralized mitigation circumstances being used by the different parties. So this then begs us to ask the question, what would happen then if a certain jurisdiction or anyone who wants to censor us, how do we cope with that? Well, I'll give you even more. If they were to censor us, and think of the situation I've mentioned with the hack DeFi protocol and how it was mitigated by the various parties, then would it be too far-fetched for me to say the jurisdiction can say to us, use whatever mechanism you've used to mitigate this and censor these wallets for me? In fact, I'll give you an even more not so far-fetched scenario where a certain jurisdiction can say to us, infra providers, give me a list of all wallets from this geolocation positions from this country, and that country. And take those, say, 10 million wallets and go to the stablecoin providers. Guys, for these wallets, can you freeze all the stable accounts in their wallets? That's why we have to be wary of centralization. That's why we have to increase our commitment to building trustless solutions. And the censorship comes so along with that. As much as those entities can do that to us, then if we're not going to be able to have alternative solutions, is the ecosystem going to end up being the efficiency layer of TradFi or FinTech 2.0? That's why we have to increase our commitment. So this infrastructure that we have, the EIP 7702 infra, number one, it is free, courtesy of the Ethereum Foundation. Number two, it is so easy to integrate with VM library. Number three, it is built on the tried and tested ERC 4337 infrastructure. There is more to it. There is more to it because it uses the shared mempool. Shared mempool is built on Gossip protocol. What it means is when you have one user operation in the mempool, it will be shared amongst many mempools. And that automatically gives you redundancy. It eliminates a centralized point of failure. And quite a lot of our clients, especially mature Web3 projects, have been asking us, and institutional clients as well, have been asking us lately to have a service level agreement, SLA, with 99.9% uptime. By us using the shared mempool, we easily can achieve that because we eliminate ourselves being the centralized point of failure. There is an added incentive. We have censorship resistance. If a certain regulator or jurisdiction says, I want you to censor this wallets and this bundlers, and as a user, I don't care. I can spin up a bundler in this open source shared mempools and process my own transaction. So it is quite important. It is important, but the shared mempool has been out for over a year. The adoption has been slow. So it is a worrying point that we might be sleepwalking to a centralized disaster at some point. And wallets that use the 7702 to enhance their usability but used a centralized bundler, they're taking a backward step. Because you've got an EOA, you're choke holding it into one bundler. Even worse, those wallets that use relays, their own relays, which are centralized in nature as well. And this infrastructure is available, will be available on 7 chains, and it has a 24-hour support for any developer or projects that integrate it. You will get 24-hour support. And we have, right now, it's rolled out on 3 chains, Ethereum, Optimism, and Arbitrum for free, and a few wallets that have integrated it. So I will quickly show you a video, just a short video, where one of our partners, the Pillar X from Pillar Wallet, have integrated the 7702 infrastructure. In this simple use case, what it shows you is they upgrade the wallet, it takes not long, and to use 7702, then you can see the EOA being used to send multiple transactions to multiple addresses. In this case, one to a distinct address using USDC, another one sending ETH to another address, both of them sent on an EOA, and you can see the transaction then going through Etherscan, and Etherscan now do have a new tab that shows 7702 transactions. So this is just showing you how simple it is to use 7702 for your EOAs and have an enhanced user experience. Now, when I show you this simple use case, think of the more complex things you can do. Not just batching 2 transactions, you can do a whole lot more as a wallet. So my section is making the case for why we should use 7702 infra, and my colleague Nikhil will take us through the infrastructure of this 7702 infra and takes us through code use cases. So thank you. Take it over.
Yeah, thanks, Michael. So this is Nikhil. I've been working at Etherspot as a backend engineer. So I'm here to speak about the technical details of 7702. I'm here to speak about the technical details of... Can't hear? Hello? Hello? Is that better? Hello? Hello? Is that better? Okay, thank you. Yeah, I'm Nikhil, so I'm working at Etherspot as a backend engineer. So today here I'm here to speak about the technical details of 7702. which involve how do you sign authorization, what does it mean to sign authorization, and what are the various steps involved when one has to send a 7702 user operation in specific, and most importantly, introduce you all to the Ethereum Foundation's new bundler infrastructure, which is built on it, which is built using entry point 9, which uses entry point 9, and introduce you all to that infrastructure, and discuss what are the various steps involved to make use of this free infrastructure. And a few key points to highlight on the infrastructure is that it's 100% free to use. You do not need any API keys, or you do not face any rate limits while you use this infrastructure. So it's 100% free to use. So yeah, we'll run a few user ops during the workshop to understand, to get a feel of how the 7702 user operations work. How do you prepare 7702 user operations? How do you sign, and how do you make use of this infrastructure to send transactions for free? So yeah, that's the whole agenda for this workshop. So yeah, let's get started. So over here I have a flow diagram which gives a good understanding of what 7702 is. And also it also gives a gist about how the Ethereum Foundation's bundler infrastructure architecture is about, and how does the infrastructure response whenever there are incoming 7702 user operations. So that's what this whole diagram is about. So assume that we have a EOA wallet connected to a DApp, which does not yet have the 7702 capabilities. Now the first step in any 7702 user operation is that we sign the authorization. Now what does sign authorization mean? The sign authorization means that you are allowing a already deployed smart contract address to delegate to it. So as soon as you sign the authorization for this particular smart contract address, which is already deployed, that means the EOA is now no longer a regular EOA, it becomes a delegated EOA. So all of its characteristics can now take advantages of a smart wallet. So it's like it can make use of, EOS can, with sign authorization, EOS can make use of, advantages like, batching the transactions, making use of paymasters and things like that. So effectively, and a delegated EOA becomes a smart wallet, but also be a EOA at the same time. So that's what sign authorization means. And how do we sign authorization is that we would need 3 things to sign authorization. The first thing is the nonce to which chain you want to connect to. And the second thing is the delegate address itself. And the third thing is the chain ID, nonce, and the contract address. These are the 3 things you would need. So once you sign the authorization, we get the RSV fragments for a ECDSA signature. So after that, the second step is to compute the 7702 auth tuple. So that again consists of all of these things along with the RSV signature. So that's what we call a 7702 auth tuple. And that's what the bundler recognizes, that this is a 7702 delegation call. So as soon as this is done, we prepare the user operation along with this 7702 auth tuple. And once the user operation is prepared, we get a hash out of it, and then that's just the regular 4337 flow. We sign on top of the user operation hash, and then that is sent to the bundler using ETH_send user operation method, RPC method. So yeah, once that's done, the bundler recognizes that there is a auth tuple over here, and makes a type 4 transaction. So now what is a type 4 transaction? Type 4 transaction is something which includes a field called authorization list. So this is basically a different version of the 7702 auth tuple, which can have like multiple EOAs and which specifies what EOA is delegating to what. So that's how the whole delegation setup happens, and that's how once the transaction is relayed on chain, the the actual operation what the EOA wanted to do, as well as the delegation, both of them happens in the single transaction. So that's how the whole 7702 user operation work. So now whatever I explained so far is if it is a standalone bundler, the bundler recognizes that this is a delegation call, and then 7702 user op, and then it relates to the chain. But what happens with Ethereum Foundation's bundler infra is a little different because of the shared mempool architecture that it follows. So Ethereum Foundation bundler infrastructure has like 2 components for it. So the first component being a proxy layer, which is again a bundler node. So what does this proxy layer do is
it accepts all of the user operations that's coming its way, and it would validate all of these user operations and save it to the mempool and relay it to the connected bundler peers. So it's like Ethereum Foundation bundler infra is not any other standalone bundler, but it has the capability to host a network of bundlers which are connected to each other with P2P, which uses Gossip protocol, of course, to relay the user ops safe and securely to the connected bundler peers. So that's why that's how the Ethereum Foundation's bundler infrastructure eliminates the single point of failure risk. Also it increases the robustness and effectiveness of your user operations getting included on chain easily. So yeah, that's that. And then once this proxy layer accepts the user operation, they are then relayed to the all of the connected bundler peers, and all of the connected bundler peers would then again send it to the chain. So that's how this works, and that's how this is censorship resistant also, because the proxy bundler which receives the user operation does not bundle it and attempt to send it to on-chain. This is because we need all of the participating bundler clients to have a fair chance to send the user operation to the chain, because of course bundlers also have a certain fee cut for the user operations which they relay on chain. So there needs a fair chance for all of the bundlers connected in this P2P network. So that's why the proxy bundler does not relay user operations on chain. It only validates it and relays it to the rest of the peers, and then the rest of the peers would then again compete each other to relay it on chain. So that's how it's censorship resistant. So yeah, that's all I had for this slide. Moving on. Yeah. So how do we integrate this whole infrastructure? The infrastructure is great, but then again, what are the next steps to integrate this? So EtherSpot has provisioned a SDK called EtherSpot Free Bundler SDK, which has a function called Create Free Bundler, which would create you a bundler client, similar to the public clients or the paymaster clients, whatever we create from. So this is just an extension of VM library, and also it's not really mandatory to use EtherSpot's free bundler SDK itself to have access to the infra. Even without the SDK, you can still have access to the infra. It's just that EtherSpot has provisioned a bundler SDK to abstract away the difficulties of creating the bundler client itself. That's all. And as you can see over the code here, there is a function called create free bundler, and then using this you would get a bundler client back. All you have to pass in is the VM chain definition to which chain you have to connect to. And like Michael said earlier, we support currently like 6 chains: Arbitrum, Sepolia, and Ethereum mainnet, along with their corresponding testnets. So these are the 6 chains which are being supported currently, and in the coming few weeks there will be more chains added as well. And yeah, this is how you create the bundler client. And also one more interesting thing to note here is that you can optionally extend this client to use for RPC actions as well. So it's not just the bundler client RPC, but it can also be used for your regular RPC actions as well. So it's like you do not have to maintain 2 different URLs. With one with one URL, one RPC URL, you will be able to manage all of your actions, all of your bundler actions as well as your RPC actions. So that's what this means. So yeah, moving on. So how do we send user operation after creating the client itself? So once we have the client, once you have the bundler client, it's straightforward. If you can have a look at the code over here. So what I'm doing in the first step is that I'm checking if my EOA account is already delegated. If it's already delegated, then I do not have to sign authorization, because sign authorization to delegate your EOA account to a different address, it takes certain gas. It's 12.5K gas, I think, gas units. So it's like 12,500 gas units you would have to pay for that gas. So if it's already delegated, then you do not have to sign authorization again, because it's already delegated. So that's the check I'm doing over there. So I'm checking if my sender code is already delegated, and the first marker which you see, which is OX EF0100, that's the 7702 initial marker. So if any EOA is already delegated, that would definitely have that marker appended prior to its delegate address. So if that contains that code, then you do not have to sign authorization. After that, you just call dot send user operation using the smart account client. I'll get to the part wherein how you can create smart account clients later. And then you specify your batch of calls, whatever you want to do. And then that can be multiple. In this case, there's only one, but that can be multiple as well. And then you get the user of a hash back. So yeah. So yeah, now I'll be doing hands-on. So these are the links that you would need if you wanna follow along. Then you can use these. So yeah, this is the documentation link. The first one is the documentation link, which is hosted on docs.erc437.io. And then there is a GitHub example wherein it has various account-specific 7702 examples. So it's on my personal GitHub. It's Nikhil Kumar 1612, and you will find a repo called 7702 examples over there. So yeah, I'll be opening that. Share screen. This. Okay. So I'll first I have the documentation open, which is on docs.erc4337.io. You will find a section called 7702 user op guide, which will have the necessary guide to
Ask if you could put the slides links again, just for taking a picture and follow on.
Yeah, sure. Can you put the slide links again?
Okay.
So they want to take pictures. They just want to take pictures.
Okay. Cool. Oh yeah, I have the documentation open. You will find a section called 7702 user op guide, which should have the necessary information for you to get started. As you can see, the first step is to install the EtherSpot free bundler SDK. And by the way, in this workshop and in this demo, I'll be showcasing how do you access Ethereum Foundation's free bundler infrastructure via the EtherSpot free bundler SDK. But you can even choose not to use EtherSpot free bundler SDK and still have access to it. So yeah, the SDK supports both npm and bun, so you can use whatever you are comfortable with or whatever your project fits best. So this is the installation step, and then I have the repository cloned as well. Yeah, this is the repository which contains 7702 examples. So I have it cloned already, so I'll be opening that.
I think it is actually possible to do it in a very cost-efficient way and have enough trustlessness.
Yeah, if you have cloned this, run npm I to install dependencies. After that, you are good to go. So I'll just create a new file called test.ts just to run a few examples, whatever is there on the documentation. So yeah, so the first thing is to get all the supported networks. So what networks does the infra support? So to get to know that, I'll just copy over this. This, and the second one is to get the bundler and the RPC URL for the chain which you want to connect to. Copy over this. I'll just add logs. Yeah, to run this, I'll run npx tsx src test.ts. So as you can see, these are the chain IDs which are supported by the infra. which is like we already discussed. It's Ethereum mainnet, it's Optimism, Arbitrum Sepolia, and the Optimism Sepolia. And notice that I don't know if you can see this. Is this better? Yeah. So notice that you can see the RPC URL over here. So this is the RPC URL which you can use to connect to the bundler as well as your normal RPC actions as well. So this is basically the URL. I did.
Just ask them if they can see it.
Okay. Yeah, so this is the bundler RPC URL which you can use to connect to the bundler. Moving on, how do you create bundler client? I'll copy this piece of code over here, the common client. So this is basically how you create the common client. You have the create free bundler utility function from the SDK. I'll use that. And for chain, I would say
hanging somewhere in the middle, and yeah, it's not very comfortable experience, right? So I hope that
I'll import the chain to which I wanna use now. I'll use Optimism Sepolia for this demonstration. Yeah, I'll be using that here.
I think it's actually quite normal, right? Well, it's pretty rare.
We chain, and then notice that I'm extending this wallet client to use, to make use of it for all of my public actions as well as wallet actions. So yeah, this is how you create the common client. Once you have the common client, we'll next see how to send the user operation itself. Also, just to show that this client can be used for both RPC as well as normal bundler actions, I'll create a function main.
I can DM you in Slack and be like, hey Peter, I didn't find something like that.
And then I'll say
I do think you're trustworthy.
a piece.
But from Ethereum's perspective, like, some other guy jokes.
Supported entry points. Then say common client dot get block number maybe. Yeah. Block PS, then the block number. So notice that I'm doing two actions over here. One is a bundler client action, and the other one is the normal RPC action. So since the the hosted network, the hosted infra supports the common URL supports for both RPC and bundler actions, I should get the result for this. And I'll call this function. Again, I'll run it the same way. Yeah, as you can see, these are my supported entry points, and this is the block number which I get now for Optimism Sepolia. Moving on. Okay, so the next step is to construct user ops and understand how do we send user operations itself. To the next section. So from an implementation standpoint, there are 3 steps that you would have to follow whenever you are trying to send a 7702 user operation. So the first thing is to create the smart account client. In this case, we will be using the account abstraction simple 7702 account, which is fairly easy to use. So we'll be using that in the example. Okay, I'll just copy over the function here. I'll just have these commented because I don't need them anymore. So this is how we create the smart account client itself. So then I need to have the owner. I'll get that. And I'll as hex. So I'll import the .env package so that it can read from my env.
Can I ask a question? Because I dabbled with 7702 before, And the issue that I encounter is that you always have to use a private key account to sign the authorization.
That's
You cannot use, like, there's no JSON RPC method
That's
to
right.
sign. Is it still the case?
Yes. Actually, there is a reason for that case also.
Okay, yeah.
There is a reason why JSON RPC accounts do not allow sign authorization.
Yeah.
Because ultimately, anyway, with Ethereum-based ECDSA signatures, it's anyway you are signing a hash. At the end of the day, be it sign type data or be it personal sign or be it sign message, you ultimately you would end up signing a 32 bytes hash. But with sign authorization, there is a security risk because like the attacker DApp or the DApp which you are trying to connect to might deceive you by giving you a hash which you can sign. If you sign that hash, that can be used to delegate your EOA account. So that's the main reason being why it's not allowed on the UI that you sign authorization. But it becomes at the same time it becomes wallet specific implementation. Like let's say you are using some wallet, that wallet would know that if I want to use 7702, that wallet would know to which account I have to delegate it to. So it would internally sign on behalf of you, but it's not presented to the user.
Yeah, exactly. Because like I've seen that like with 5792, the wallet send calls namespaced, the wallet namespaced ERPC like RPC methods like wallet send calls. The implementation of how to batch multiple calls is left to the wallet. And for example, MetaMask is actually using 7702, but it's doing it as part of the wallet. It has my keys. It makes me sign, like, I'm making an RPC request to the wallet. The wallet internally process it and say, oh, I need to make the user sign this thing. But like, this is a walled garden because, like, first of all, it's left to the implementation of the wallet.
That's
like, your mileage may vary depending on which wallet are you using, and then it makes them more powerful. Instead, I cannot basically build a web app relying on the fact that the 7702 will be used or not. Like, I actually want to be purposefully build a web app that leverages 7702, but at the moment, because of the absence of the sign authorization method, I cannot, right? So I don't know. Basically, I don't know how to get around these things. I don't want to hijack the thing. Maybe we can.
No. Yeah, we'll maybe connect later because there's only 10 minutes.
Yeah,
left.
yeah, absolutely. Yeah,
we
sorry.
can connect later. Yeah, that's fine. So yeah, moving on. How do we send the user of itself? I was in the middle of copying the private key and things like that. Some import issues. I'll do that. And then so this is how we create a smart account client. So in this case, we are using the two simple 7702 smart account utility function from the VM itself, which will give you the smart account client back. And after using this, yeah, so the next step would be the same thing which we discussed on the slides. We'll add this and see if there are any import issues. Sparse units. Yeah, that's all. So this is how you send the user operation. I'll run this now.
Try to do the swap and hope for the best, and in most cases it works, and if it doesn't, then, well, tough luck.
I think I'm missing my private key over here. I'll just grab my private key directly in this case.
Most. But again, I would say that versus
Add this private key here.
Uniswap code or some other version which is like
So as you can see, this is my wallet address, which is both my smart wallet address as well as my EOA account address. So this is the user operation hash which I get back. So I'll try now and open this on the Explorer.
we don't want the UIs to be able to upgrade your contracts. And we, first and foremost, we want these risks to be...
So if I can head over to internal transaction, you can see that there was a transaction 14 seconds ago. So this is basically using the Ethereum Foundation's bundler infrastructure. Actually, it went to the RPC node, and one of the connected bundler peers took that transaction and relayed it on chain. So yeah, that's how you do it. And then moving on to the documentation section. So yeah, if you want to have your 7702 user operation sponsored, then what are the extra steps that you would have to take care? So I'll be speaking about that now. So all of the steps are still relevant even if you want to have it sponsored. The only extra step would be to create a paymaster client. When you are creating a paymaster client, you would have to add the paymaster URL. Of course, now I don't think there are any paymasters which is supporting entry point 9, given the entry point 9 is very recent. But once we have paymasters supporting entry point 9, we can use the paymaster URLs here and create paymaster clients. And then all we have to do is during the send user operation, just add the paymaster related details here, and then you'll be able to sponsor your 7702 transactions as well. uh, so yeah, if you guys wanna like try out the Stack Blitz also, we have Stack Blitz integration also over here. If you can open this should like clone the free bundler SDK repo itself, which is on this GitHub over here. I don't know if I have it open. Yeah, this is here. So this is the free bundler SDK, whole repo, which has an examples folder and a, like a usage MD file also, which you can use, which gives you like a minimal command line terminal, which you can use to just try out 7702 user operations. So yeah, that's one way. That's another way of trying 7702 user operations. Okay. And then moving on now, I'll speak a little bit about account-specific examples. In this example, whatever we see here, we had a utility function from VM so that you could use that to create your smart account client. But what happens if you have your own custom wallet implementation? Because all wallet implementations are not the same. They behave differently. Like the signature schemes may be different. The way you sign user operations might be different. So how do you do it if you have a custom, 7702 wallet implementation? So I have a few examples on my repository over here. For the sake of for the sake of this example, I'll be choosing Amber over here. I'll head over to send.ts here. So yeah, I'll try to give a walkthrough of what are the various steps I took to make it work for the wallet which I've chosen here, because VM inherently doesn't give you two smart accounts for all of the wallet implementations. So what I had to do over here is I had to create a smart account client myself by using two smart account VM library utility function from VM. So when you are creating a smart account client for your custom wallet implementation, you would have to specify all of the fields needed, like the entry point. This is the new entry point address, by the way, and then I'm using entry point 8 ABI itself because it's still compatible with entry point 9 also, and then because just to be type safe with VM, because VM doesn't know anything about entry point 9 now, so that's why I'm reusing the entry point 8. And over here also I'm specifying the version entry point 8 because VM doesn't know anything about entry point 9 currently. So just to be type safe, I'm using entry point 8. And then how do you encode calls? That's basically what goes into the call data field of your user operation. So that's that. How do you encode calls? How do you batch transactions for your particular smart account implementation? So that would have this details. And then decode calls, it's just the opposite of what encode call does. And the authorization, like your private key account which you just created, and then the implementation address itself. So this is the address which holds the implementation details for your 7702 account. And then how do you get address? Because this is a 7702 account, the EOA address itself will be your smart wallet address also. And then how do you get factory args? This goes into the init code section of your of the user operation struct. And then how to get stub signature. Stub signature is something which will be used during estimate user operation gas call. So this is the stub signature which will be used. And then how do you sign message? All of the details. In this case, it will of course be using the owner private key account. And then how do you sign type data, which is 712 signatures? How do you do that? And then the sign user operation itself. So I convert the user operation to packed user operation to be compliant, compliant with whatever is there on Solidity. And after that, I'll get the user operation hash back, and then I'm decoding it because of the wallet implementation which I have chosen. This is all specific to the wallet which I've chosen now. And then I get the 712 data for the user op, and then I sign the signature and return it back. That's the implementation for sign user op, sign user operation. And then yeah, rest of the steps remain same. You check if it's already delegated or not. If not, then sign authorization and then hit send user op. I'll try to run this now.
Solutions so that is a viable you can kind of control that.
So yeah, as you can see, previously I used the same account to use a different thing. So that's why you can see the the authorization over here. For some reason it failed. Let's take a look.
We still give you the highest rating. So if you can provide that, then I'll be like promoting your protocol left and right. What about yeah, trustless is, I want trustless to actually be I want to do things that the trustless makes the protocol better for the users. Like it's not just a nice to have, it actually makes
I think there is a mistake on the delegate address which I used over here, but you get the idea. So that's how you use account specific examples to send user operations. So yeah, that's all I had. And moving on to the slides back, I had a slide on do's and don'ts of the of 7702. So basically, it all comes down to the wallets because they are the gatekeepers for your 7702 delegation. So it becomes very important on which wallet to trust and which delegation address they choose. And then the storage collisions, the smart contract developers for 7702 implementation, it becomes important because the address space is same because it's the EOS address space on which all of the code resides and the storage resides. So it becomes important for wallet smart contract developers to have actual logic or implementations in place such that the storages between multiple delegations do not collide. And then the broken assumptions like TX origin should be equal to message.sender, those are no longer relevant. Yeah.
Any questions?
Yeah. Do you guys have any questions? I can take questions now.
Yes, we're out of time, but do you want to say something quick?
Thank you very much. We will answer your question offline. Yeah, we can. Yeah, you can just take it off and sit down.
I guess we can continue on what I was saying earlier. Like the bigger question is like, how can we use this in a web app essentially? Because like in a web app, I'm connecting my wallet through the wallet connector, for example, and through that I cannot sign the authorization, right?
This is more of a implementation detail for wallet developers itself. Like let's say if there is some other XYZ wallet which is a browser plugin over there, and how do they sign authorization and then send 7702 user ops. If your web app is relying on already existing Chrome plugins like MetaMask and all of that, then this does not become relevant to those because MetaMask would have their own procedures or things like that to send transactions.
So if I add to this, ultimately, 7702 brings a risk in that imagine you are a DApp and you say to me, can you delegate your account? And it could be a malicious DApp. So for that reason, when 7702 was approved, it was decided the wallets would be the gatekeepers so that a wallet would say, unless we've got it on a whitelist, we cannot allow any smart contract to be delegated to. So obviously that brings the issue you've raised. I think, is it EIC
5792.
Yeah, so
wallet send call.
Exactly,
Yeah,
you can check with that. So if you're a DApp, you can check, is this EOA or is it smart account? Because basically when you have a 7702 wallet, it satisfies the smart account. So it becomes onto the dApps on basically to have a fork EOA, smart account. Other than that, until we get enshrined, if this is opened, every EOA is going to get hacked. Think of the calamity.
Yeah, I get it. Yeah, it's just that, as you said, they become the gatekeepers, and so
yes, they become the gatekeepers. At least what we are arguing about is do not send it to centralized bundler because
Sure.
you bring in the EOA to a centralization and you are introducing a new risk. At least put it on the shared mempool. That's what we're arguing.
So yeah, I mean, I guess all I understood, even the security concerns which are valid, but ultimately, like, what is your advice if I want to build a web app that, because I'm actually doing it, we're doing it with Compose, we're batching multiple calls, and as of now, we're using just ERC-437, but it's a pain in the butt because you need to move funds every time.
Exactly.
From the EOA,
Exactly.
Right? Like this is, to me, this is the solution.
Yes.
But as the app developers, I cannot use it.
Yes, so
right?
basically, it's for people like us, we have to evangelize the wallets to adapt 7702. Whether they use the shared mempool or even a centralized bundler, at least in terms of usability, it would address your concerns. Because
it's just like in the specific case where on a test net, right? And so I cannot go to MetaMask and say, hey, please, can you deploy your delegation toolkit on my scrappy rollup that it's going to be alive for another 2 weeks before we tear it down? Like, you know what I mean? So the whole thing that we're building is ephemeral by nature. And so basically, because of the wallet gatekeeping, I cannot leverage this, right? You know what I mean?
yes, I mean, not the specific infra. I completely agree with you. So when you talk about the MetaMask, they would only allow you whatever they've rolled out.
Yeah, or I'm talking about MetaMask, but in general.
Yeah.
You know,
So what we are trying to do is we're trying to get more and more wallets to use the shared mempool. As soon as they do that, then it would be available on all infra supported.
Gotcha.
Otherwise, as you said, it would be up to that wallet to say, are we going to deploy our infra? So I do feel you. I do feel the frustration.
Yeah. I think it. Yeah. It's just it's in a way it's a valid problem, but it's kind of separate because for me, like, my problem is the sign authorization bit, right? Like, because as you said it, like, for security reasons, it's like demanded that the wallet do it, but like I have to go through them.
Yes, they're the gatekeepers of 7702, no doubt.
And will they remain, in your opinion? Like, should they remain that
when
way?
we get to 7701, enshrined one,
Gotcha.
it would be protocol level. No one is the gatekeeper. You don't use the bundlers, this, that, and that.
7701.
Yes.
Okay.
So that would be the ultimate aim, to enshrine this into the protocol level.
Is there a roadmap for that? Did you know?
I think a couple of years or so, because it would require a hard fork.
Oh, okay.
So the whole point is trying to avoid the hard fork. Unfortunately.
No, I get it. Okay. All right. Thank you. Thanks
Thank
a
you
lot.
so much.
Good job.
Yeah.
Thank you.
Okay, can you guys hear me now? Great, cool. So, hey everyone, I am Greg from ENS, and we have Tate here as well. Today we're going to be talking about interoperability in ENS v2. But before we talk about v2, is this working? Nice. Before we talk about v2, I want to take a step back and talk about what is ENS in case some of you guys don't already know this. So the Ethereum name service is a decentralized, permissionless naming protocol that lives on Ethereum mainnet, very specifically. And the most basic level is that we turn complex hex addresses into human-readable names, right? So instead of typing OX179A, so on, into a wallet, I can type gregstroll.eth, and that is my on-chain identity. That is a pointer to my wallet. And this just sounds like a username, a name to an address. But really, over time, it's become more of a profile. And so this is a look of my ENS profile. I do have the address, as you can see, but I also have a description that I like baking and building apps on Web3 protocols, and an avatar image, and all these other social protocols, and addresses on other chains as well, EVM and not. And so this is kind of what becomes my portable Web3 profile. Another look at how you might see this in an app. On one hand, you connect to an app and it shows you your address. This doesn't mean anything. A Web2 user that's coming into crypto sees just a random string of numbers and letters, and this is meaningless. It's not personable at all. Whereas with ENS, you have a more personable connection into your app. You sign in, and you have a name, you have an avatar. This feels like my account, my portable Web3 profile. And not to be like shilly, but ENS has been around for a while. There are over 1 million active .eth names and hundreds of integrations. All of this is to say that it's worked pretty well so far. But in order to scale to what we want it to be, and for the average user to be able to use ENS and register a .eth name without kind of understanding all of crypto, we need to improve. And so if you have registered a .eth name in the past, you may have seen a screen like this. And there's a lot going on, so let's kind of point out a few things. First is that there are 3 steps, and these 3 steps take at least a minute to complete, which is kind of slow. Users aren't used to waiting a minute just to do something in an app these days. Next, you'll notice that when I took this screenshot this morning, gas fees were over 10% of the actual fee of the name. And when you think of it in percentages, this is just kind of crazy for normal users. Web2 users are not used to this. We kind of talk badly about credit card transaction fees, and those are significantly less. And again, this is on a good day. There are times where the transaction fee is multiples of the actual fee. And speaking of the fee, it always has to be paid with ETH on Ethereum mainnet, on L1, which it is increasingly unsafe to assume that the average user has ETH on L1. And so these are kind of some of the problems that we see and that we seek to solve in the next version of ENS. But just a funny way to think about this is that ENS sees itself as a user experience protocol. It tries to make crypto easier to use for users, but actually, our own user experience isn't the best. And so, the experience of registering a name. And so this whole upgrade of ENS v2 is trying to improve the UX of ENS so that we can better serve the whole ecosystem as a user experience protocol. And so what does making registration easier look like? It looks like some of these things. A user should be able to register a name quickly, starting on any chain, starting with any token, in less than 2 wallet interactions, which we have today. So obviously we don't want to make it worse. They should be able to use any wallet. They should be able to use any client, meaning any website should be able to implement this stack that we're about to talk about. It should be completely permissionless and as trustless as possible. So these are kind of the requirements that we have in building out ENS v2 on Namechain. And this basically makes it obvious that ENS needs some sort of account abstraction. You need account abstraction, you need chain abstraction, all these things. But actually, when you look at the current stack of account abstraction, it becomes clear that the exact pieces don't solve all of our problems together. And so we have to come up with a little bit of an innovation on top of the existing stack. And so that's what I'm going to bring Tate on to talk about.
Hey guys. About account abstraction on Namechain, the current account abstraction options
are essentially between two sectors. We've got wallet-based and app-based account abstraction. On the wallet side, we've got 7702 or a straight SCA implementation with like a passkey signer or something. And on the app side, that tends to be just standard SCAs. So with wallet-based account abstraction, our issue generally is that it requires a specific wallet. 7702 is a great specification. However, many wallets, unfortunately, do not implement 7702, and as such, we can't give the benefits of 7702 to every single user, like all of the account abstraction stack. And that's a significant problem for ENS because we want to reach as wide an audience as we possibly can. We want to be globally inclusive, and even if the biggest wallets support us, support 7702, that is not 100%. It's never going to be 100% in terms of getting an ideal flow, but we'd much rather be on the higher end of maybe 90% or more. Yep. So app-based account abstraction is the other main option, but it's only the app that can touch the assets if you're using this method. The issue with that is that we don't have any freedom for the user built in to do whatever they want to do. Migrate to a different wallet, use the functionality of names through a different system, etc. Or if you don't want to have the app solely authorized for anything, then you need explicit authorization from the user, which is an additional wallet interaction. And as Greg was mentioning before, one of our requirements is that we want to keep it to 2 wallet interactions or less for registration. And for any other interaction on ENS. Then the alternative to both of those things is having some sort of lookup system that every application can implement. So to outline a specification of what we really want is account abstraction, but you can use any wallet. You can access it with any supported app, or if you have an unsupported app, it should still work via a user's wallet and on both Ethereum and mainnet and namechain. That is another crucial step in that we can't have a chain native solution because ENS v2 spans multiple chains, not just a single chain, and we don't have, well, we have a say, but we don't have any control over what happens on Ethereum mainnet. So what we're creating are hidden contract accounts, or HCAs as we're calling them, and essentially it is just a dedicated SCA or a smart contract account implementation, but with a lookup mechanism built in. The lookup is really just a mapping, and that mapping is really dead simple. This is nothing insane. This is not some crazy new architectural decision that we've decided to make. It's a simple mapping, and it enables the benefits that we want to get for SCAs for every user, like basic multi-call gas sponsorship, and everything that's beyond that hasn't been discovered with modular accounts, as well as what I'll go into detail in a sec about in-browser burner signers, which is allowing us to keep our wallet interaction limit very low, and in some cases even be able to achieve a full registration process in a single wallet interaction, which is really nice. So the lookup is just on an HCA factory contract, and it's just one HCA factory contract, and it recognizes a single implementation, and it can maintain a mapping of a HCA address to an account, so that you can do a reverse lookup whenever you need authentication for anything. For example, if you are checking for ownership authorization, then you can use your HCA and the ownership authorization checking message sender will then use this lookup using the HCA address and resolve it to the main account, where it will then be authorized to do exactly the same thing that the main account would be able to do without any extra steps beyond that, and is very simple to implement. So on the implementation, we've chosen to go with OpenZeppelin's pre-existing context pattern, which establishes a message sender function that you should call instead of message.sender whenever you're using a Solidity function. And we're just replacing it with HCA context, which I'll show you in a second. And it's a very simple implementation, but for a developer who wants to utilize HCAs, this is literally all that you need to do from a contract side to be able to recognize HCAs. And then once you're part of that ecosystem, you get all of the same benefits that all of our protocol contracts are going to get as well. So that's not something that I included here, but all of our protocol contracts will recognize HCAs just as they would recognize accounts. And so you just need to initialize it with HCA equivalents, which again, I'll show you in a second. So let's look at some code. Let me just enlarge this a little bit. So we've got the HCA equivalence function, and it's the message sender underlying implementation. All it's doing here is we're just checking for a factory address, and then we're going to do a lookup on the factory for an account owner from the HCA address, if it is an HCA address, assuming that there's no insane hash overlap, that will just return 0 if there is no main account, aka if it is an HCA, if it is not an HCA. And so we're just going to return the message sender. Otherwise, we're going to return the account owner instead of the HCA. And so then all of your ownership checks, all of your permission checks, if you're familiar with ENS, name wrapper fuses would theoretically use this lookup instead of any custom authorization logic on top. And we're implementing it in HCA context itself, just like this. So all we're doing is we're just replacing, so this is the OpenZeppelin context contract, and it just defines a message sender function, and we're just replacing it with a call to our HCA equivalents, and that's all it is. It's dead simple, but that's the implementation. As for the code itself, the SCA itself, we've got someone from Rhinestone here who can take you through a video of a demo, I believe. Let's quickly put that up. Take from there. Yep.
We're good. Can you guys hear me now? Nice. Well, thanks for coming, guys. I'm Conrad. I'm from Rhinestone. Been working with the guys at DNS. So yeah, essentially kind of continuing on from what Tate was talking about with the HCAs. I wanted to show a quick demo in terms of what the whole experience looks like. Obviously, this is just kind of like a demo app and not kind of like final UI. But I guess I'll walk you guys through the whole experience of kind of using the HCAs, but also kind of seamlessly going cross-chain. So starting on Sepolia and going to base Sepolia. In the future, that will obviously be kind of the ENS name chain. But yeah, I guess let me get started with the demo. So obviously here we just have some demo UI. Is this full screen? Does that work? Shit. Okay, never mind.
So how to
never
talk
mind.
with the...
Anyways, so this is the demo. You kind of connect the wallet. You can just connect any EOA that the user has. And I guess the important part here for the demo is just showing that we have some USDC on Sepolia. And then pausing here quickly, it spins up an HCA, as you can see here on base Sepolia, which in the future will be on name chain. And the idea is that this HCA, I think I'll show that in a second on the Explorer, doesn't have any funds, it's not really deployed yet. It's kind of just like the user comes with the EOA, doesn't have anything else. And so like no balance on base Sepolia in this case and name chain in the future. And then the idea is that the user wants to be able to go from their existing funds, whether that's USDC, ETH, or any other token, to name chain and buy the domain that they want, both atomically and quickly, and also without needing to worry about bridging. The idea as well is that it doesn't kind of have to be Sepolia or mainnet, it can be kind of any other chain that the user can move from to name chain. So entering some domain here, which is available, and as you can see here, the user doesn't have any USDC balance on base Sepolia, but it has balance on like normal Sepolia. So under the hood, when the user does the ENS like registration process, which is what was mentioned earlier, it will also atomically bridge and kind of do that in one go. So that's the commit process, and as you can see here, the user just has to sign a message, which is actually a permit to message. So anyone that has used like DeFi before, like Uniswap, for example, you will have like dealt with permit to before, and that allows you to spend your tokens kind of just with a signature instead of needing to actually make a transaction. And actually going back a second, you can also see here, like here in the bottom left, that the payment token is USDC. So the user doesn't need to have like ETH necessarily, and like I said before, and I think as Greg mentioned earlier, that could be any token in the future. Like the user can literally just rock up with the latest shitcoin and pay both for the fee for the ENS and for the ENS domain and for gas kind of with that token. So going back, the user will just sign the permit to message, and then the transaction will first happen on Sepolia and then kind of on base Sepolia. In this case, because Sepolia is pretty slow, like the block times are like 12 seconds on average, it takes a second, but depending on the chain you're coming from, this will be faster, and also when it's on mainnets, it'll be quite a bit faster. And as you can see here, so far, there's just been a single interaction that the user has signed. So when this transaction has gone through on the destination chain, you can see that the commit, which is the first part of the ENS domain registration process, has gone through on base Sepolia. And as part of that, obviously the user has paid the fee, as you can see here, in USDC. And once again, kind of as I mentioned earlier, there was no USDC, no gas tokens, nothing that the user had on the target chain. So it's a proper kind of app chain experience where a user can just go from funds they have anywhere and just interact with this new chain that they don't even necessarily know about. And kind of showing the user account again, this is now a deployed HCA that has some tokens as well. So then kind of the second process is the actual kind of reveal or the registration step. And as you can see here, there's no wallet pop-up anymore because this is all handled by the local session signer. That's kind of the signer of the HCA on the target chain. So the user just press register and it pretty much instantly goes through because like the app chain, in this case base Sepolia, is just super quick. And then, yeah, just showing that. You can see here that the ERC721 got minted, which is the user's domain. And that's pretty much it. One thing that is also kind of like very easily possible with this is if the user wants to do multiple domains, they can also do everything in one kind of interaction, kind of bridge enough funds to actually register multiple domains so they don't have to even go through that one-click experience. But yeah, that's kind of like the experience. As you guys saw, like the user didn't have any funds on the destination chain and it was just a simple one-click experience. Yeah, that abstracts away that the user even gets a smart account, but also that they're actually interacting with another chain. Obviously in this demo, this was kind of like shown quite well, but I think, and the people at ENS have been working on great UX there, where actually a user interacts with an app on an app chain, but doesn't even know about that because they never have to think about bridging. They never have to like actually realize that there's another chain involved. They just think these are the tokens I have on whatever chain, and everything is super smooth, instant. I can pay gas in whatever token. So yeah, that's kind of the final experience we're going for, and super excited to see this live in prod.
All right. So now that we've had that demo, I thought might as well take you through a little bit of the protocol code as well as like at the implementation in the protocol. This is the namechain repo. So some of these contracts will just be on namechain, but a lot of them will be deployed across both namechain and L1. A little bit confusing, but bear with me. So we've got an ERC 1155 token contract, and this is pretty much a standard 1155 contract, except we've just got an additional owner of function for ENS compatibility. So all I'm going to do is search for the context. So we've got HCA context here, and we're just inheriting HCA context, which is what I was showing before. And that is literally the only thing we have to do besides a... Do we actually have it here? Oh, right, it's on the registry itself. All I have to do is search for equivalence. So this is a contract that's inheriting that 1155 contract, and it's just got an initialization of the HCA equivalence, which is, if I can click through, just our containing our function from before, and it's got a reference to the HCA factory. There's only one HCA factory. And that is the only thing that's required because we're already using the message sender helper here instead of message.sender. So anywhere that we use underscore message sender, it's going to be able to detect and replace an HCA address with a standard address. And yeah, so it's completely that easy. There is nothing else to it, and I'll continue on. I've got a few extra things to say here. So we've got the in-browser burner signers, and that's what's removing those extra wallet interactions. We've got an issue with the in-browser burner signers in that users will just sign things they don't understand occasionally. And if the browser signers have unlimited permission, then that can be potentially very dangerous. At the ENS protocol level, this is sort of equivalent to like a 7702. Not exactly the same, but the potential scope you could have in authorizing an in-browser burner signer is the same as a delegation on 7702. So we're reducing it in scope to reduce danger, as well as that the burners all have expiries so that they don't leak, or if you get compromised or something from a data breach a long time ago, etc., that's nothing to worry about. It's all stored locally though, in browser. It's never going to leave your browser, at least our implementation won't leave your browser. It's up to an app to make sure that that is the case, rather than a wallet in some other cases. So for execution, you can use intents, but you can still utilize 4337. Intents are crucial for user understanding, and you can execute it with unrelated data from the SCA or HCA implementation itself. But as a fallback, 4337, which is extremely widely supported, is still there in the case that you urgently need to execute something, or if you have specific infrastructure that you want to run in a different way outside of the intents framework, you have the ability to do that. As for upgradability, we can only have one current implementation, but users can be on older versions. So we'll have just a standard set of versions from 1 all the way forward, and those versions can all be utilized by a user at the same time, not one user, but many users. So we can't restrict just to one implementation, or we don't want to restrict to just one implementation, because users should have the option, in case of a malicious DAO activity, to maintain their SCA as is on the current implementation. Or if they just don't feel the need to upgrade, they don't need to upgrade. And the DAO is the only authority that can authorize updating the current implementation to newer versions. The reason we have to have one specific version is, again, because of safety. We don't want a user to be able to assign arbitrary full access to the INES protocol on behalf of their account, because like before, it's similar in scope to 7702. It's pretty much just a delegation, and delegating is dangerous. Most wallets won't let you delegate to, or all wallets essentially won't let you delegate to a generic 7702 implementation. They all have their own, or none at all, and that's for safety. They don't want random contracts, or end user really doesn't want random contracts acting on their behalf all of the time and having unlimited authority. And I was saying before, the user doesn't need to upgrade, but they can upgrade. And when they upgrade, they can only upgrade to the current implementation, not to prior implementations in case of bugs or issues where an upgrade is required. So what is that solving? It's faster registration or anything with name chain. We can use any chain and token via solvers and relayers of Rhinestone. And we can, in two wallet interactions, register a .eth name with an in-browser signer involved. And it's permissionless. Anyone can execute either via intents or via 4337, which is very widely supported across the industry. It's also not completely trustless, but is trust minimized with an in-browser signer auth. Execution itself is still trusted to the extent that you could have, you could be front-run by your solver or relayer for the registration transaction. This is something that we'll be working on over time to try and prevent, but generally the financial incentives don't align for a solver or relayer to front-run a name unless it is explicitly going to be profitable immediately for them to do so. So some future improvements: atomic cross-chain swaps. This is because name chain is based, and so if you are an L2 and you are also based, and we're settling at the same layer or even using the same pre-confer, we can guarantee execution of a set of transactions on both chains and guarantee settlement at the same time. Unrestricted burner support is something that we would like to add, but again, the unlimited scope for those burners is very problematic. So we need wallets, or at least some wallets, to be able to support parsing what the consequences are for signing access for the wallet, for the signer itself, the burner signer, and potentially making it entirely trustless. Not currently sure how that's possible, but it's something that we're looking into. And so, yeah, that's about it. If there are any questions or queries, then I think there's time for that now. No?
So I get like the HCA stuff as a mapping for when you're doing the registration.
We can't hear you.
Can Can you hear me?
Yeah.
Yeah, okay. So I get the HCA thing as a mapping within the context of registration. Are there other like ENS like adjacent features or functionality that you think HCAs relate to? Or is it really just kind of like isolated for registration?
So registration is the most crucial component up front, but it is technically, like the HCA stack is applicable to any transaction and every transaction on the ENS-v2 protocol. The use case for that is more limited in scope if you are looking to just do like a single transaction, because you still have to authorize an in-browser signer as an authority on the HCA. So if you're a random DApp and you want to set an avatar record, you can't do that without any wallet interaction. You still need that one wallet interaction. So for apps that are deeply embedded in the ENS ecosystem, it definitely makes sense to be implementing HCAs. Like if you're creating subname systems or creating intricate resolver systems, then it makes perfect sense. But for everyday, like non-ENS specific DApps, it's not really very useful.
Okay, so it wouldn't be crazy if I was like, yeah, I could like attach session keys to like a record update that's associated to my HCA or something.
I'm not really sure what you mean.
Like I update my record and then it signs so that I have like a session key and suddenly I have this window to do stuff. Does that make sense?
Nope.
No? Okay, I'll ask you off stage.
Okay. Yeah.
Hello, can you hear me?
Yeah.
Yeah, I think it was Tate with the demo. You mentioned that you spin up an HCA in the browser.
So we spin up the in-browser burner signer, which is authorized on the HCA.
I cannot hear you now. Okay.
Can you hear me now? Yeah, okay. We spin up a in-browser burner signer that's going to be authorized on the HCA via a signature from the user's wallet. So we're not spinning up an HCA in the browser, we're just spinning up a burner signer.
Okay. I don't know if now's the time or potentially after, but could you elaborate on like what that actually means in practice and how it's done?
So it's just like a ECDSA signer in browser, like in a secure storage location.
Okay, so you're literally just generating a private key and
Yes,
signing on the file.
literally just a private key.
Okay, perfect. And then I think it's actually to Conrad. In the demo, it's obviously a demo, but I'm curious how to, in the context of the current environment, how that bridging was so quick. Yeah.
Wait, can you hear me?
Yes.
The question was, how does the bridging work?
Yeah, how does the bridging work and how is it so quick? Because my understanding is in practice, at the moment at least, that's the kind of main constraint and the issue with user experience is people having to wait for a long time.
Yeah, so that's traditional bridging. There's kind of a new, I guess, paradigm for bridging called intent bridges, which is kind of like, well, I guess it is the intents that Tate was talking about earlier. So the idea is instead of kind of having these canonical bridges where you either like lock up an asset on the source chain or burn it there, and then it gets minted, and then I guess it gets passed through some messaging bridge and then minted on the other side. You instead have these sophisticated actors called relayers or solvers, and you essentially, it's kind of more complicated than that, but you essentially send funds to them on the origin chain, and then they give you funds on the destination chain instantly. So they already have capital, like inventory, on the destination chain, and they would then give it to you there. Does that make
So that exists now and it really is that quick?
Sorry? Wait.
So that exists now? That exists now?
Yeah.
Okay, perfect, thank you.
Thank you for this illuminating talk, Tate. I wanted to ask you about the HCA factory that includes the mappings. Is that right?
Could you tell us a little bit about how those mappings will work, how that data is maintained and then updated as well?
So it's just a one-time operation. So there will only ever be one HCA for any given account. So on the first instance of needing to use an HCA, it'll be deployed, and that mapping is just trustlessly set in the factory contract itself. It just knows what the contract address for the HCA will be for that user, and then it sets the reverse resolution. So it sets the HCA address in the mapping to be equal to the user's account address, and that is stable throughout the entire lifetime of the user's account, or like as long as the chain exists, that mapping will be the same.
And unique, and no possibility of some kind of collision or duplication?
The potential of collision is about as likely as the potential of a collision for generating any account. So, yeah.
Okay, great. Thank you.
Yeah, no problem. Any other questions? Nope. Great. Thanks, guys.
מדבקה. שומעים אותי? Can you hear me? Can I get the headset over? Yeah. I want to understand how I hear myself.
Yes, I was going to show you. Just
Okay.
You have two on the table, or you can make it in your presentation.
Okay, 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 great,
Perfect.
great.
Same for you.
No
just
delay.
You are making Q&A later.
It could be a workshop, so yeah, it could be Q&A. So, might need.
Hello, can you hear me? Okay, I have something that. 1 2 1 2. 1 2 1 2. Okay.
There's a slight delay from your voice. I understand. That's why I want to check that there's no delay.
But if you don't see the number, you just press the button.
1 2 3. Yeah, okay, I hear myself. Great.
It's the same.
Yes.
One, but it's the same.
Okay.
And this one is the button.
Okay. Thank you.
You have HDMI.
Yes. The side. Oh, this side. Okay. Again, which area? This square.
While you are speaking,
Okay.
the area for lighting and touch.
Okay. Are these showing anything? It shows my screen? Or no? נראה דנית. בסדר? צריך לעשות משהו. Hello, can you hear me?
Can you start?
Just a second. Excuse me? Is there a mute?
A mute in this one? Yeah.
Ah, sorry. This is not that. Don't interesting me. Can I start? Okay. I hope. I really hope there were going to be less noise. My name is Dror. We worked on the EIL, and I'm going to present the EIL SDK. A quick overview. I know you probably heard it. EIL is a cross-chain protocol to do decentralized token transfers. And the SDK is the tool that you, as a developer, can create an operation that spans multiple chains, and it abstracts away all the logistics of moving assets from between different chains. So this is the EIL SDK. you can download it now, and you can download it later if you want to try. I will try to explain the APIs, to explain how it works, and maybe walk through and see it, the application runs. Okay, what is the SDK? It is a TypeScript library that lets you do everything you need to do to make a cross-chain token transfers with the protocol. This is an overview of the protocol. Basically, the classes that you're running with the protocol. You start with the SDK. The SDK is the wrapper, the overall wrapper that you work with. Now, in order to create a cross-chain operation, you bring up a builder. You create a builder contract. And from it, you spawn multiple, what we call a batch builder. A batch is a set of operations that you run on a single chain. We are using ERC 4367, obviously, underneath. So each batch is eventually a single user operation that runs on a single chain. So you create multiple batches, one for each chain that you want to run. Within each batch, you run an action. An action, it's a single call. Again, it's a bit abstracted. We'll see it later. You can have a simple method call, but we also a higher level like token transfer. And I'm not sure if it's here or here. They created with the Stitch project, if you've seen yesterday, they created multiple DeFi actions like I want to lend, I want to use specific protocol. But basically, an action is a wrapper for a method call or a set of method calls that you can use. Once you created, you use the cross-chain batch builder and you create multiple batches, it's time to execute them. So you first build all the user operation out of these batches, which requires checking that there are providers, checking that the balances across the chain, and then you hand that out the output to what we call the executor. The executor is a contract that runs these user operations, like executes the first user operation, waits until it's executed or failed, probably executed successfully, and if this user operation requested a token transfer to another chain, then it waits for the tokens to appear on the other chain through the bridge and execute the next user operation. So basically, it wrapped everything, but it's a single execute call. We'll see that. These are the core contracts of the SDK itself. We have multiple helpers. Everything is multi-chain. So we have a multi-chain contract. It's a wrapper that around a contract that can have different, either the same address or different addresses across different chains. And obviously, the most useful one is a multi-chain token. We have one in the sample we see. We have USDC on multiple chains, and we also have USDT on multiple chains. And you can bring up your own object with multiple addresses. The idea is that you usually work with this multi-chain object, and you don't really care its address on the current chain, because when it is added to a batch, it will use the right address. And of course, the account itself, you as a user have an account, so it is a multi-chain account. It's a wrapper around a smart account, and it manages all the interaction within the different chain, manages the nonces on the different chains, everything when it needs to deploy and everything.
If I may contrast it with how you used to work with user operations and event transactions before the EAL SDK. So you would need to create an instance of a smart account for every chain you were working on, and the same it will go for a token. You would have a set of configurations for every token on every chain, and the same goes for an action. You would have to build a batch action if your smart account supports it for a chain, and then you would have to repeat this action again for a different chain. So here we allow you to do the building once and signing once using the appropriate classes and appropriate APIs for the cross-chain operation. And the difference is like cross-chain is when you actually intend to do something across the chains, and the multi-chain stores the data that spans multiple chains for you to use in your application. So.
Okay. And we are talking at the API level, but at the UX level, obviously, the most important thing that a multi-chain smart account we want you to do is sign at once all the user operations. A simple one, if you have a private key, it's very easy. Sign for all, because there's no UX, so there's no UX even to sign multiple times. We did some work with Ambire, so you will be able to do a single signature on a single dialog to sign all the user operation, and then you can run them through. Okay, I'm now going a bit deeper. I'm going to see to show how we're using the SDK. The first thing you do is you bring up the SDK. It can receive parameters in order to define what chains it is connected. At the moment, it is connected to we brought it up on a testnet, actually on a Tenderly-based testnet. So it has 4 networks. It supports Ethereum, Arbitrum, Optimism, and Ethereum mainnet. But you can bring it with more. Right now, it is built with these 4. I create my account. I create my multi-chain smart account, and I pass it the owner, that will be the entity that is signing for them all. And I create a builder. We'll see in a moment how I use the builder to create all the batches inside it. And also we started for this sample. We created an instance of USDC. I assume, I think I put it into the file, the token file, which actually I didn't put it into the slides, but basically it's an array of chain and address. I need a list of chain and addresses. This is what I need for a token file. From the SDK, it connects to the connected networks that the SDK is currently supporting.
If I may, I don't know if the future slides will elaborate on it. We can see here that we create an account from the private key. It's like one example that would require like your application to have a direct private key. But the account class here, when it's passed to the builder, it's just an interface. So either you can implement it or wallets can implement their own account wrapper, and we will be shipping with a number of account implementations where it can be using like your injected account for sure. So like you need to prepare the multi-chain smart account with the appropriate API, and then you pass it to the builder, and then this account will be used to control your multi-chain execution.
Yes, the presentation I built around a command line application that uses this multi-chain account, and actually it's a simple one. It's signed separately using the owner. We do have, as I said earlier, the Ambire account that can connect underneath, and it has a UX, and then it prompts you once to sign all the user operations. Okay. Now we're seeing a batch. This is a sample batch that we created with Cross-Chain Builder, because if I show the API of the Cross-Chain Builder, it's a single function, start batch. So in this example, can you see them? Yeah, you see my mouse. I started the batch on a specific chain, let's say Arbitrum, and I want to perform some actions on this chain. We'll go deeper about the actions. You can see I added a transfer action. I give the token. Again, it's a multi-chain token. I don't care about the address, because the batch will run on a specific chain, so it will know what address to use. I forgot to fix it. Of course, I cannot transfer to 0 address as recipient, and I specify the amount I want to transfer. It could be, this is a very simple, simplistic example. Of course, you probably want to do some DeFi application. You can also call make a function call on whatever contract you like, and pass it parameters. And now we're getting to the juicy part. I want to perform some operation that will go to a different chain. This call with the voucher request. The model that we have is that you make a voucher request. It's a call you make on-chain, so it is an action. Basically, it becomes an action just like any other action, like tokens transfer or whatever. a voucher request saying, I'm locking these tokens on this chain, a list of tokens, here is one, and I specify what the destination chain I want these tokens to come. This is a call I make to the contract of the EAL on chain, and it will make a call and lock this for a period of time, like 1 hour, on chain. This is also the end of the batch. Usually, transfers you usually do at the end of the batch after you're doing some other stuff. Should have written a better example before that, like swap something. So I end the batch and I start a new one. The next batch, not surprisingly, is running on the same destination chain of the voucher. This is a simple flow. I go one after the other, but a flow can span more than two. And I started a batch of the destination chain. And I specify that this batch should use the above voucher. I have the ID of the voucher. I specify I use that voucher. This will tell the SDK when we build everything that the second use operation first can only run if there is a voucher, if it received all the transaction. It cannot be submitted on chain because everything it's executed later, there's no another action in the example, but can depend on the fact that the tokens were transferred, the amount will be there. It is impossible to execute this code without these tokens arriving because using a voucher means I expect all these tokens to be here. It is impossible to do it otherwise. And another thing it means that we don't deeply say within this presentation is about gas fees. When I created a voucher, I also said, and yes, I will pay gas using the first token I specify in this request. The example here is still using 0 gas fees. We don't deduct this value, but it should. And then it means that the second user operation that runs on the second chain is already prepaid for. Like the fact that it can use this voucher means that the provider that I'm using agreed to pay for this voucher, and I'll get the money with the voucher deduct.
I just want to clarify. Okay, so let's go one by line on the sample code here. So when the builder, okay, that is the cross-chain builder, it starts a batch. In our case, a batch is just a set of function calls that you would like to call on a specific chain. The source chain here is just chain ID number, nothing else, just the simple chain ID number, 1, 10, doesn't matter. The transfer action in the second line is a convenience call for what we call an action. That is, an action in our case is just a wrapper for a method sig, basically a method call inside an Ethereum smart contract. The third line is doing exactly, this is just a sample code, it's doing exactly what the second line is doing. So the function call action is a way to show you that the function call is just an arbitrary call to just a target that is, in this case, USDC address, and the function name of what it does. In this case, the function name should be transfer and not call, but basically this is just an arbitrary way to call an action on chain. It can be any smart contract with any ABI that you like.
I think I explained it before you came.
Okay, sorry.
Yeah.
All is slow.
Okay, so I will say, like the A you see, like it can look weird, but the fact that you can name your requests, it doesn't make any sense here because you have 2 chains, but you can build arbitrarily complex, nested, looped structures with the SDK.
Not loops. Anything but loops.
Not very much looped, but like.
It's a directed graph.
Directed structs, and then you can just select which vouchers go to each batch.
Yeah. And in our case, we just demonstrate one source chain and one destination chain, but technically we allow any number of source chains and any number of destination chains and any combination of these.
One more. We keep saying source and destination when there's an example of 2, but it could be a 1, 2, 3, 4, 5 listed again. Someone skipped the line. It can be a complex acyclic graph. So for a single operation, there's a source and a destination, not for the entire graph. I think some of that we covered on the previous time, because this is a batch builder of a single chain that performs the execution, and pass a user operation, pass action to them to build so that eventually will create a user operation.
Okay. Yeah.
No, we don't have slide. I'm not sure we're going to talk about now, but
okay, we don't have an example in this code snippet, but as you can see in the third point, okay, we support runtime vals. Now, runtime vals, what it's supposed to do is basically if you don't know how much you want to send. For example, if you add an action in the source chain that just swaps on Uniswap, and you don't know the exact output of this swap, and you still want to use it to transfer it cross-chain to the destination chain. So what you would need to do is add a runtime var action that basically specifies that you want to take the balance of in your account post-swap, okay, after the swap, and then just use it inside a voucher request. We have a sample code for that in our repo that we will show you. It's not in the snippet here.
Basically, you add an action that makes a static call and save it into a variable. And then any request, it can be a voucher request, but also any other request can reference a runtime variable and use it. And it's a value that is only exists during the execution of the call. Like usually a balance off, but it can be anything. Any method that returns byte 32 add value can be used in the future functions. Okay, we talked about it. Action is an abstract method call, internally implemented as an encode call. So encode call is very simple for simple functions. It can be more complex than that. So this is a simple action that we showed earlier. It's a transfer action. Gets usually a token, recipient, usually an address. Again, can be another multi-chain entity in using the addresses on this specific chain. By the way, I forgot to say, if anyone has a question or something is not clear, please stop me. So we'll be able to clarify them. And this is an example of the implementation of encode call. We take your multi-chain entity, you take the address on the current chain, you receive the batch so you know which chain this is encoded. The encoded is on a specific chain, obviously. And then we return an internal function call object, which we clearly understand.
So what you see here is basically the underlying implementation of transfer action, which is basically doing what function call is doing, but instead of having in the function call when you do add action, when you need to specify all of these fields here, we just added a convenience function in this case because transfer is so common that it can be used like that. And we have several other conveniences like that, but basically all of them can be used as a generic function call.
Yes, and in many cases, you can see this function. This is the place where we resolve multi-chain entities into the specific chain addresses. We can see that in this example, we actually didn't. The recipient is required here to be a address. It can be easily extended to be a multi-chain object. So you don't need to specify the address specifically when you're doing
you do take in the second line, you do take the token address from other sources.
We're doing it for the token, but not for the recipient.
Yeah.
So the token itself is always a multi-chain. It can be. It's a sample. One important thing to notice is that an action is encoded as a sequence of calls, not as a single call. In many cases, like an action will require, for example, approve. So it is. So you can create an array, return approve this and that token, execute the execution, maybe approve 0 to make sure I don't have dangling approvals, and this is a batch that defines what the action I'm doing. If you go in the code later, voucher request is exactly that. Perform an approve and then make a call to the underlying function to the code. Okay, this is another, we saw it earlier. This is a generic function call name. One thing to know that you specify a target, you specify a function name. You can specify the ABI if you need, but a multi-chain content for convenience holds the ABI. So, like this can be implemented. This is a real implementation because my contract can hold its own ABI. You don't need to specify specifically for each call. Okay, now we're getting to the part that we have the execution. The cross-chain executor takes all the batches we created and convert them into user operations. It also takes all the vouchers and validate them on the destination chain they have to make sure that there are providers that can provide them. At this point, if you, for example, you're using a token that there is no provider that currently has a balance, it will revert before you even start doing anything. It collects the addresses of all the providers that can provide and put it in the user operation. And create actually the list of user operations to be executed. Everything I said is packed into this single function, which is called build and sign. It first builds the list, connect all the chain, collect all this information, and then it triggers the accounts sign. I'm not sure with that. Okay, the multi-chain account, we added a function which is called sign user operations. It signs them all together. And it said we are defining an RPC call to support it. We worked with Ambuyer. So on Ambuy, it will pop you up, show you all the user operations, so we'll be able to sign them together. And then after you finish to build and sign, the next thing is to execute. Execute is a multi-step operation. It's not that you just wait for it, because at the minimum for transfer, you execute a user operation, you wait for it to complete, you wait for a voucher, you submit the second user operation, wait for it. There are at least 5 steps, and as we know, if anything can go wrong, it will. So you have at least 5 places that can fail. You do want to know where you are, at the minimum, to show a progress in the UX. So we have a callback that gives you all the information you have. The index, you created a sequence of user operations, so it's a sequence number of your batches. Type, the most important, of course, is failed, but we can see internally the other cases, like we created the user operation, we submitted the user operation, we're waiting for a voucher, we just received the voucher, great, let's continue to the next. You have the transaction hash once user operation is there, and chain ID. A user operation also contains internally the chain ID.
Dror,
yes.
There is a question? Yes.
Can you give me a microphone? Because I cannot hear.
I just had a question about the cross-chain executor. You're saying each batch is single chain, but you can put together multiple single chain batches to execute cross-chain with the executor.
Yes.
Right. Okay.
The idea
like you don't have cross-chain, like the batches themselves are not multi-chain.
No.
No.
Okay, we have cross-chain batch, which is all the batches, and for each chain we have.
So let's go over the structure again. The SDK has as the main class the cross-chain SDK, which gives you a cross-chain builder. Now, this cross-chain builder, you can start with it, like I think you start with start batch or create batch, I don't remember, start batch, and that returns you the batch builder. Now, this batch builder you can for a single chain. Now, so it's 2 layers of builders. One of them is building the cross-chain batch, the cross-chain operation, and each cross-chain operation has a batch builder that builds for a single chain. Okay? So in this case, this builder is actually the one that is the cross-chain builder. So after you start batch, okay, and you added all the actions to the batch, then you start another batch, for example, for the destination, add all the actions that you want, the voucher request, using voucher from the source, then you do builder.build and sign, that is the cross-chain builder that returns you an executor. Okay, so in this case, you already have all the user operations on all the networks built and signed, and the executor, as Dror rightly said, accept a callback that right now this callback is very simple, but it can do much more elaborate things, and it actually is missing some fields here for convenience that we added just for you to be able to have more information. You will see them in our repo. They are well documented, the fields that the callback is getting. But yes, so you have a cross-chain builder that gives you single batch builders, single chain builders that are the batch builders, and they return you each one of them the cross-chain, the user operation, and eventually you have the builder that builds all of them together, builds and sign, and yeah, that's it. That's all.
Okay. This is okay. Some helpers on the multi-chain tokens. I want to show you a demo of this application. Sorry? Sorry, yes.
So if we have like,
just a second.
In that simple example you showed where it was just like a source chain and a destination chain.
Yeah.
On the simple example you showed where there was just a source chain and a destination chain, you had the like add voucher requests, like you added one voucher. If we were to like have an extra chain in there, you would need to create another voucher for that second chain if you wanted to do something like.
Yeah, okay, so if I'll give you an example. So suppose you have multiple source chains, you can ask for vouchers on all of them, just add voucher request on all of them. And then, first of all, this voucher request is designated for a destination chain. So if you have one destination chain, of course, all of them will be for one destination. You still have to specify the destination for each voucher request. But then on the destination, you can use all vouchers, which is a convenience to just use all the previously requested vouchers. Or you can use voucher per voucher that you're calling. And if you're calling with also multiple destinations, then you just need to specify for each destination the source vouchers that you're using, as I said.
Okay, I'd like to, as an example, think of if you have a blob for all the actions you run on each chain, and then a voucher is the arrow. It's a request on one chain, destination on another chain. So you can have just two with an arrow between them. You can have three in the list. You can have one that span multiple requests, use on different chains, and collect it into one chain or going elsewhere. As long as this graph doesn't create the circles, it's okay. It is okay that the same chain will be used twice. For example, if my flow means move my tokens to another chain, perform an action there, and move back to the same chain, it is possible. It's another batch on the source chain. It is okay.
And that's where you were talking about if you don't know what the amount that is going to be after the chained operations, this is where you can set a percentage with the add variable.
So, for example, if you have, I don't know, if you have a very good aggregator of a DApp aggregator, some sort of a DeFi aggregator that you want to use, for example, for elaborate swaps, and you have the best prices for USDC to ETH on Arbitrum, but the best prices of wrapped Bitcoin to ETH on Base, then you can do all of these elaborate swaps in like from source to destination, then back to the source, and we don't enforce any restrictions on this. Besides, again, for this graph to be acyclic, just in order for us to be able to resolve it. But that's exactly what we are aiming for.
We didn't say. Everything we do in EIL is the same token. Like you're moving, the token can have different addresses, but it is the same token. You're moving your tokens from one chain to another. We are not handling any pricing. We don't have oracles because it should be the same value. You can build different protocols on top of that, but when we are saying swapping, that you always go use DEX. For doing all those swaps.
Okay, we don't prohibit sending an asset, one asset to a different asset on a different chain. We just don't natively support it in protocol. So it's not that we enforce that they are not the same. We just don't have any way to know whether they are the same. Okay, so that's why it doesn't.
Okay. And a small thing, like you can actually move this variable across chain using a special key that you can create in You create a session key in your in an SDK, and that allows us to append not only the voucher itself, but also some extra data. So you can create a runtime variable and move it across chains and resolve the, for example, the price of a swap on Optimism. You can move this data next to Arbitrum, even if like you didn't know that, and you don't need to use an oracle or message passing. It's just a part of the SDK. Session key. So like
we have session data.
Session, yeah, session data is the signed data of the session. It's a
session data is this. I'm not sure we'll be able to go into session data.
Yeah.
This is a sample program that we have. Actually, it's the sample program we copied into the.
So to simplify, I think to simplify the flow, if you guys were in yesterday on any of the talks about EAL, so EAL mostly focuses on 2 or 3 things. One of them is cross-chain asset transfer. The second is multi-chain execution and multi-chain gas abstraction. So in our case, the cross-chain asset transfer is simply add voucher request and use vouchers. This is literally the cross-chain asset transfer. The multi-chain execution is adding arbitrary actions, as we could see, on all the networks. And the gas abstraction comes natively from the protocol, where you pay with the first token on the voucher request for the gas on all the destinations that you're using. So you can pay with 1 token on all the execution on all the networks.
Okay. Now, I just want to see if I run this test program. So it starts building everything. This is my account. It created the batches. It doesn't take. It's synchronous. It doesn't do anything. Now it's building the user operations. It's a bit slow, the network, but it works. That's good. It executing the graph. We are seeing they execute the first transaction. It completed the first transaction. It waited for a voucher. The voucher was issued. Now it's executed on the destination chain. It doesn't show much. It would be better if, in terms of our progress.
The demos yesterday were better in terms of what they showed, but this is just to show the
code that runs
the SDK itself. It's not about the demo.
Yes. And it timed out. Sorry. Never demo online.
Is that CLI example code on the GitHub, or is that on your GitHub?
Yes, so everything Draw currently runs is on GitHub. We have actually other repos as well that we are going to provide you with links for. I'm not sure that they are in this presentation, but we will provide them in our GitHub repos, and you can see all the information, all the more elaborate examples for what we did, and hopefully you can build up on that. And if you have any questions, of course, come to us, ask us. We are here.
We have a demo with React and VM, and we have a CLI demo for like different scenarios.
Yeah. The demo is working both on Sepolia's networks. I think we deployed on Arbitrum, Base, and Optimism Sepolia, and of course mainnet Sepolia, it's Sepolia. And it's working on our DevNet from Tenderly, thanks to the Tenderly team that provided us with a long-term DevNet that also has more elaborate tracing and all the features that you know from Tenderly.
With the idea with the Tenderly, it's a fork of the real network, so you can use more for whatever.
Yeah, exactly.
You
can use
something you can't do on.
You can use for example, the Uniswap addresses and Compound and whatnot.
And Stitch is like a full-fledged like DeFi platform working with EAL internally, like just pure EAL. Stitch app, yeah.
The Stitch app,
yeah.
Yes,
it is
open source.
Sorry?
It is not in the Infinitum repo. They have a Stitch app repo. I will get the link. We're making sure that it is linked here too. Any more questions? If we talked about runtime vars. Let's say that I'm not sure it will work, but. Sorry, for a runtime var, what you do, you make a call to a transaction. Like, I'm not sure that I'll be able to add it here. No, actually, sorry, I'm not.
Don't go doing a sample. We have several samples of runtime vars and how to use them. We don't have to show it here. But I think that while it is complex because it's a more complex concept here, but it is still relatively intuitive in my opinion.
Yeah, the idea you add an action, the action set var action, it makes a static call, and save it into a variable, and then instead of a variable you use runtime var. This will revert if I run it because it is not set, but it will use it inside the execution of the application.
Okay. In the meantime, are there any more questions? Something that you want us to elaborate on?
Hey, thank you for doing this. Can you please show what is like the token file where you get the USDC address from?
Yeah.
Okay.
I'm just wondering, like, in the case when you have fragmented liquidity.
I have here.
The token file is simply an array of.
So it's just arbitrary input, right?
Yeah, it's an arbitrary input.
Yeah. Okay. Thank you.
Just chain ID and address.
Let me go a bit back about an overview of the SDK. There are a lot of things you need to do in order to do cross-chain application, like querying oracles, all the usual stuff you need. The SDK is concentrated on making the actual cross-chain transaction once you know what you want to do. So yes, we do need a set of addresses for tokens, and we assume you have a good source for that, because this is not something we can provide. We cannot even attest that these addresses are correct. But if you specify invalid addresses, like when you create a voucher, when you pass a multi-chain token, you actually say, I'm looking for this token address on my chain, and I'm going to this token address on that chain. This is the value. And if it's a wrong address, then probably no provider will execute it, and you'll time out because it's not a valid. Or if you just like you ask an invalid token, we're not validating the token, but
okay.
So we do assume they are the same address because there is no pricing queries here. So it should be the same token, the same value. So a provider will accept and do it.
Yeah. Okay, thank you.
Yeah, and like to touch on the question about like fragmented liquidity, you will be able to collect your liquidity using the AL. So it's not like as fragmented anymore. You just create multiple what we call voucher requests, and you have like multiple source chains, just a single destination chain, and then you can collect like 100 different chains into one, and just wait a little bit for all of them to arrive.
Okay. Now, yes, and the SDK right now is mostly the primitives. An example: if you have a fragmented liquidity and you want to use, I want to use my USDC. We can create a set of batches that run your USDC from whatever chains you are and do some operation with that. Right now, it is manually. You need to know on which chain and run a batch for each of those chains to collect it to one chain and do the operation. Like you do it in your dApp. We do want some of this, to have helpers inside the SDK.
So actually, for touching the helpers, as you said, this SDK that we are showing, this is the pure EAL SDK that should do the basic stuff, the basic things that we showed you. But there is already, for example, the Stitch demo, the Stitch app that Ophir showed yesterday. They built on top of this SDK another SDK that just wraps and gives you more convenience methods for swaps, for different DeFi actions that you can use, and just as more elaborate primitives instead of just implementing them yourself. Okay. The Stitch, the Stitch
SDK. We need.
We'll
find it. We'll send it to you.
Join the Discord, and we'll share the your own Discord.
Yeah.
What Discord?
We will have a Discord.
No, kidding. We have a Discord.
We have an account of such in Discord.
Yeah.
We don't
And
have-
then
No,
like
it's not
another
in the
small
team.
thing like
It's
the
technically our organization Discord. We have a Discord,
have a
guys.
Discord.
Okay.
We have a Discord. Don't worry.
We cannot advertise the
the-
Discord.
And we also have it already in GitHub. It's just that the Ophir that built the Stitch API, he put it in his own GitHub repo, but that's okay. It's also public and it is accessible by anyone. So we will just post the links in our GitHub and in our Discord, and you can use that.
Yes, someone behind.
Yeah, sorry.
Here is a Discord link. If I don't know how to put it on the screen. Sorry.
For something like a cross-chain like token transfer, on the destination chain, there would have to be some kind of LP for like providing liquidity on that side,
Okay,
right?
yes.
So would there be like an LP like fee as well, and something
Yes,
to
as I
take
said, there are
count?
gonna be fees. Yes, there is an LP that listens. Everything you see here, there's no server except nodes. The clients we connect to the network. All the communication is done on chain. I request a fee by a transaction, and the provider give it by issue a transaction on the chain, so I can take the voucher. I didn't go into the deep into the flow.
To clarify, because I think it's a great question. There is a fee mechanism that is part of the protocol. It's part of the protocol itself. We just hid this fee inside the SDK because we have, in our opinion, a very reasonable way to adjust the fees. But the way it goes, it is a reverse Dutch auction. That is, the client, the user actually specifies the fees, and the increase in time, the fee, how much the fee would increase in time in case the transaction isn't included. So it can, for example, just include a very small fee for the XLPs, for the liquidity providers, and the fee will increase as much as the user specifies in case no liquidity provider see that as profitable enough for it to include. And it can also include a maximum fee that it will reach. It doesn't matter if time passes, it will no longer increase more. But basically, the user very much controls the fee. Yes, so you ask if there is a way to estimate it. So yes, exactly this is what we do. We already look for previous liquidity providers and see like the average fees that they are taking, and we are taking something a little bit lower than that and post that as the reasonable assumption of what it would be a reasonable fee in our case. Okay. So we put some reasonable defaults, but it is configurable.
What happens if you create a voucher with too much value? Is there a refund mechanism at the end, or like unused voucher amounts?
What do you mean? Okay.
More than liquidity can be provided on.
There's a voucher is either used or not. Like if you make a voucher request, for whatever amount token. If no one accepts it, you'll time out. You will be able to unlock.
You will need to wait for a timeout, which is about an hour.
Less than an hour.
The SDK will handle it eventually. Right now, it doesn't. Withdraw this amount because it's yours, and to continue without it. If the voucher is used, we showed here only the example of a voucher of a single token, but a voucher can be multiple tokens. So it is either all this voucher is accepted or nothing at all. So there's no unused voucher in that case. There are edge cases like a voucher was issued, there was a real voucher, but your transaction that uses this voucher reverted. Now, this is an unclaimed voucher. It was already used, so you cannot claim it on the source chain. The provider can already claim, you cannot get it for yourself. What you can do, and we will do, is do a mechanism that, a fallback that will either, depending on what you want, create a voucher back to move it to the source chain, or if you like, you can continue and create another user operation to run it from the destination chain.
Like the money is never stuck. Like if the operation reverted, the money is available to you. It's on your account, just on the destination chain. Like the thing you wanted to happen didn't happen. But yeah.
So at the moment it is locked, and you need a specific manual API. We do the SDK will add it so that it will automatically or half automatically will get it back to you.
To clarify the flow, when you add a voucher request, it literally calls a function that requests the voucher on chain. This function deposits the tokens that you want to send to the other side in the cross-chain EIL contract. Okay, and this contract is basically waiting for a liquidity provider to call issue voucher. So if any liquidity provider issue the voucher for you, then the wallet is going to take this voucher from the event and post it in the user operation, as we do with use vouchers. Okay, and that will then transfer the amount on the destination chain. Now, if this voucher isn't used, if the voucher request wasn't fulfilled, then it has a very short timeout, and then the wallet just can withdraw it again from the deposit in the EIL contract. So it's not like it's locked only for the expiry of the voucher request, which is minutes.
Any more questions?
Yeah, maybe add a conspirational. Like we expect the wallets to do more and more integration with the EL. So like for now, the SDK is written for the DAOs, but it's useful for the wallets, and wallets can embed it and like use the features that we are providing. But as time comes, we expect it to be more of a wallet thing to support EL, and for applications, they may not even like need to like add an SDK, and they will be able to use, for example, like send calls API to just like express their like cross-chain intention and just use that.
Basically, we do expect that the application will do, of course, will do all the batch building, because this is part of the application, and the sign and execute will be done by the wallet. So once we have that, the SDK will almost stay the same, but we'll use more of the wallet in order to do this stuff. It requires more to define the standard to interaction with the wallet for status, for running the engine inside it. But so right now we are using the wallet only for the signature, the multi-chain signature, and all the SDK is running on the application side. Okay. So we're done. Thank you.
Okay.
Thank you.
Thank you very much.
Yeah.
Another question? Yeah.
So I heard that there was a docs page on a URL that dropped this morning, but I haven't been able to find it. It's not on the EIL/SDK README or repo, but I saw earlier like actual docs from the earlier workshop. Can you put that up?
We do have a docs page.
I'm not sure about URL where it is.
Tom is here, happened to be here. Where is the doc page? Like, what is the URL?
Yeah, the release was yesterday, so like.
Yeah, it went live yesterday night. It's available at docs.ethereum.interop.layer.com. No, docs.ethereum.interop.layer.com.
Like this?
You can open it, I think. You have.
I wanted to get rid of the underlying. It's open.
Oh, you just do it.
Yeah. I could also open the Discord now. Okay.
Okay, so while the SDK currently looks like with very basic building blocks, as we said, like for example, every developer that wants to contribute and add maybe a more elaborate building blocks and maybe use something like what the Teach guys did, that would be awesome for us. We're accepting pull requests for that, and that would also make the effort for the community much better. So if you're using a certain dApp and you're already implementing all of the functionality to actually batch reasonable calls to that DeFi, then it would be awesome if you could also open a PR for us. We will add it as just a native block builder. Yeah.
Tom, do you have any information about the hackathon?
One second, sorry. So we do have another workshop on Friday, the 21st, at 5 p.m. Workshop room 3 for anyone who's going to the ETH Global Hackathon, that is. And we also have a bounty, 3 prizes, 3, 2, and 1K. We're basically looking for projects that will take the EAL SDK and build cool stuff with it and demonstrate what you can have when you have, trust minimized, seamless UX. So yeah, again, Friday, November 21st, 5 p.m., workshop room 3.
Thank you, everyone.
Okay, thank you. We are still here.
Thank you.
Yeah.
Thank you.
Okay. Gracias. Can you hear me? Is it working? Can you hear me? Check 1, 2. Working? Okay. Right on. So, hello everybody. It's rather distracting with all the sound, so I'm going to look at you guys, and if you have anything to say, put your hand up, because I would like to make this as interactive as possible. I'm going to talk about faster canonical bridges with multi-proofs. So the canonical bridge is the bridge that is the one that's enshrined in the rollup where the ETH goes to Ethereum through. Now, there's a few things here. First of all, before we get started, I'd kind of like to get a sense of who's in the audience. Do we have anybody from bridges or liquidity providers of any sort here? Awesome. Okay, you probably have some context to add at certain parts. I would love it if you have anything to add. Just put your hand up. We'll get you a mic. And do we have any folks that are involved with proof systems or other of any sort, whether it's from other rollups or any types of bridges with other proofs? Cool. Okay. And same thing for questions. So we're going to try to make this as interactive as we can in spite of the format. I'll try to get you a microphone if you need it. Okay, cool. So we're going to basically cover 3 big things. Why faster is better, what it actually means to speed up the proof and make it faster, what are the parts of the proof that actually take the time, and what are
the options to give faster proofs. So why is faster better? The thing is, most people just think, well, all right, I use a cross, I use some other fast bridge. I don't use the chain's canonical bridge. And this is actually true. So you are not necessarily sending just Ether tokens to L1. You're probably sending them to some other chain. And most people use these types of bridges. So there's a bit of a misconception that the speed of the bridge doesn't really matter because nobody uses it. But actually, there are some issues with the bridges that people do use. So like mint and burn bridges end up trusting the issuer. So if you use Circle's CCTP bridge, for example, like this is free, it's pretty fast, but there's an example of a different kind of trust assumptions. And the real thing is the liquidity providers, they actually have to provide liquidity. So that has a cost. They have to rebalance from one chain to another. And the longer that takes them, for them to move, if there's like a net outflow from a certain chain, the longer it takes to do that, the more that they have to have capital locked up, and that has a cost. In the end, that cost gets passed on to the users of those bridges, and so we want them to be able to withdraw more quickly because that just makes everything cheaper and better for end users, even when those end users are not using the canonical bridge. Okay, so what does faster mean? So first of all, I want to get something out of the way. Withdrawal time is not the same as finality. This is a bit of a side topic, but just it's kind of a point of confusion. The finality, when we're talking about like say an optimistic roll-up taking 7 days, it doesn't take 7 days for the chain to finalize. The finalized roll-up chain is really, first of all, it's determined by the node, and that's the source of truth. If you have access to a node, you query its API, that is the canonical version of what is final. And just so that you understand how that ties back to Ethereum security, what the node considers to be canonical is what went basically round trip through Ethereum, got finalized on Ethereum, and the L2 blocks were derived from the finalized Ethereum blocks. So in this chart here, you can see on L1, the green blocks are the finalized blocks. The L2, the blocks that were derived from the data in blobs in the finalized L1 blocks are the finalized L2 blocks. Okay, so that means that the L2 node is the actual source of what's finalized, which is essentially not instant, but it's quite fast, right? It doesn't take days or even hours under most conditions. But the bridge also needs to be able to check the final state of the rollup, the finalized state of the rollup. The bridge is just a smart contract on L1, so the bridge cannot actually query a node because the smart contract can't really do that, and that's what proof systems do. So the proof system lets the bridge know what the state of L1 is. Sorry, know what the state of the L2 is. Okay, so let's dig into what actually makes the withdrawal time. There's the time for the rollup to finalize, but we'll kind of ignore that because that's not very long. There's the time for the proof to resolve, and there's waiting time to make sure it resolved correctly, and we're going to dig into what those mean. So proof resolution is the time until the bridge sees a final, it's the time until the bridge sees the outcome of the proof that it trusts. So that means different things for different proof types. For an optimistic dispute game, it means either the 7 days has passed without a challenge, or the challenge occurred and then the whole dispute game was played, and in the case of optimism, a step of the L2 chain derivation was performed on chain. In the case of a ZK proof, it means that the proof was verified on chain. So these are the different types of proofs we have. So there's like the interactive dispute game, which is slow. There's ZK, there's TEE. So the dispute game, right now it's 7 days. So what if we just speed that up? Now, we could do that, but there's L2Beat has some good guidelines, and I think what they started with is that it should be 7 days. Well, that's the current definition of stage 1. So the challenge period has to be 7 days. Now, the reason why is because in 7 days, if there was a censorship attack on L1 and nobody could play the dispute game to dispute an invalid output route, somebody could actually finalize an invalid withdrawal. So if you have enough money at stake on the L2 and you have enough capital to do a 51% attack on Ethereum, you could prevent the L2, in theory, from posting, you could prevent anybody from playing the dispute game. So they thought, okay, well, what would be the solution to that? It would be a hard fork, and that could take a week. I think there's all kinds of things that you could debate about the realities of that, but anyway, that's where we are today. That's kind of the part of the baked into the definition of stage 1. Now, recently, this V. Buterin guy posted on Ethereum Magicians that maybe it's okay to allow stage 1 rollups a shorter withdrawal window. So let's dig into that. Now, you could have, by the way, if you have questions, I want to just say again, just jump in, put up your hand if you have anything to add. So, okay, we have some options here. What if we had 1 to 2 days of the dispute game, and then we had an option where a security council member could just flip a switch and extend it to 7 days in the case of some kind of censorship attack. That's the suggestion. So I think this is a good suggestion. I think it would help, and this would allow the happy case to resolve quickly. Say 1 day if nobody challenges it, or if there's no. Well, it's not if nobody challenges it. It's if nothing unusual was happening in terms of censorship on L1 and no security council member decided to flip the switch. This is actually not an issue for optimistic ZK because if you have no proof generated, it's going to resolve. It's just going to be a liveness failure. So this is mostly not an issue. It's an issue if you have to challenge, but it's not an issue for generating proofs. You don't need to worry about having a long period of time to generate proofs. Okay. Looking at the time, there's a bit more we can dig into there, but I'm gonna move past it. So that's the dispute game, the interactive dispute game. But there's better options. There's fast proof types, right? So we have ZK. ZK is fast. ZK can be decentralized easily. That's pretty much all there is to say about it. So that's actually a great choice for speeding up this part of the proof process. There's also TEs. That's another option. Very fast and cheap, but it cannot be decentralized easily. So for a single proof type, this is a bit problematic. I mean, it might actually be suitable in some cases for some chains, but I think as a general case, it's not a good suggestion on its own. The reason why it can't be decentralized easily is because you have these physical attacks. So you have to trust the operator. I think this is fairly well known, but this is a bit of some links to follow up on if you're interested. there's also chain of trust attacks because they use a cert chain, a certificate chain like TLS. So the same sort of issues that you have with TLS. This doesn't mean the TEs are bad. It's just you have to know what your threat model is, and they have some uses. They do give you more verifiability of some centralized infrastructure. So I think for any of the centralized infrastructure that chain operators are running, it is actually good to have those inside a TEE, because if it's done right, you can actually be confident that they ran the exact version of the software that you're able to audit or look at. The attestation can commit to like a specific hash for a boot disk image or whatever, and you can actually verify all of that. It gives more protection for the operator as well. So, for example, against your proposer's key leaking, which also may not matter in a permissionless situation, but this is just like depending on how you're set up, this is an interesting benefit. And one other thing about it is that you can actually use your TEE in a stateful way. Nobody actually does this right now, and most people don't like the idea, but it is just something to think about. You can just run a node inside a TEE and have a smaller diff between what's, okay, so your node is the source of truth. Your proof system is supposed to represent the node as well as it can, but the proof systems have a little bit of extra infrastructure to become stateful, a little bit of extra code that's written, that's more surface area for bugs. So there is maybe the idea that you could just literally run a node with some state inside the TEE. It's kind of a little bit awkward for a lot of reasons, so I'm not sure if it's a good idea, but it's a possibility. You need to verify your L1 inputs, for example, so it would be, I suppose the naive way is you run an L1 node inside it, but that's kind of terrible. Maybe you verify your L1 inputs as part of verifying the outputs, but anyway. Do we have any TEE people in the room? We do. Okay, if you have opinions or thoughts on this, let's get you a mic. Do you have anything to say? Yeah, you look like you have something to say.
So, hello everyone. I'm Yoxin.
I cannot hear you. It could be me. Does anyone else hear? Oh, okay. It's probably my. Oh, because my sound is off. Oh, now it's not working. Okay, try again.
Hello. Can you hear me? Okay.
Maybe the battery's dead on this thing. Okay, now it's working.
Hey, I'm Yoxin from Automata. I have been working on TEs for years. I think TE has a good point, has advantage and disadvantage. The advantage is that TE is ready to market. It is compared to ZK, it is kind of easy to use, and you can just get the TE from the cloud providers and just put your, especially we are talking about the VMTs. You can simply put your workload into the TEs without any modifications, and then you get the proof, and everything is easy. And in this case, TE kind of because it uses the hardware to do the end-to-end encryptions, and this kind of encryption protects the workload confidentiality and integrity at runtime. In this case, I would say no one can easily attach or modify the workload running in the TEs. However, from the other side, TE is very complex. It's super complex. It has many layers from the because take the AMD SCP example. All the SMP TEs is managed by the firmware, and the firmware is nowadays closed sourced. We cannot easily verify we cannot easily verify the firmware, and it might has a lot of bugs. We don't know. That's why a lot of security people can launch the side channel attacks. But since we already found a lot of bugs in the firmware and we already submit the patches, in this case, I would say we already raised the bar for the attackers to attack the TEs. That's why I think TE is a good solution for the multi-prover system. Although there's might still bugs, but I think the bar is higher and higher for the attackers.
Yeah.
Thank you.
Thanks. And I should say that Automata has a framework that they've built for OP stack chains that verify with the TE. Okay. So those are the options for speeding up the first part of your proof time. Now you have a fast proof, it resolves quickly. Now we need to reduce the second part of the withdrawal time. So most blockchains have a waiting period after the proof resolves. So this is after the proof is verified in the case of ZK. The reason why is because we don't trust the proof system. So every proof system probably has a bug, whether it's been found or not. It's just a matter of time until somebody finds it. If that happens, then we need to be able to react. And right now, stage 1 rollups have a security council that can intervene in exceptional cases. So if there was an invalid output route finalized, then you need some time to be able to react. You have some monitoring and time to react to that. This is in the OP stack, it's called the proof maturity delay, sometimes called the air gap. I think zkSync calls it the time lock. These times vary, but they're at least a few hours typically. So in order to reduce that, you just need to trust the proof more. How can we do that? Well, there's a few ways. You could, in theory, have a trusted proposer with a fast lane, right? So this doesn't necessarily reduce the decentralization. It just means that in the average case, in the normal case, if the rollup operator is proposing with a trusted proposer, then it's fast. And then if other people are proposing permissionlessly, it would be a bit slower. This is obviously not ideal. It's just, it's an option. You could potentially do that in a TE, but kind of a similar, more general way of doing that is just add more proof types. So this is what we mean by multi-proofs. So you're going to have to verify 2 different proofs in order to allow the withdrawal to proceed. There's another option as well, which is not really available to existing rollups without a lot of modifications, but just to put it on your radar, there's this native rollups project. There's, in the future, there will be an execute precompile, which essentially allows you to run the state transition on L1 exactly the same way that L1 would do it, which means that it's bug-free. Bug-free means that if there is a bug, it's a bug in Ethereum itself, and presumably that would be fixed somehow by forking Ethereum or whatever the solution is. But it's the same it's the same bug in Ethereum that would exist in the L2. So that's a future option that looks pretty interesting. Oh, and if you, yeah, we'll actually have a link for that later for some more info. Okay, you could add a second ZK proof. Yeah, right. Let me get a mic.
Thanks. Yeah, I mean, for the native execute precompile, it's still pretty unclear how you actually provide the necessary witness data for that to work, right? Like when the data could be.
I lost your sound. Sorry, one moment. It's back.
Yeah. Okay. So it's all about the witness data that would be necessary for the precompile to make sense. Like it could be several megabytes. You know, for example, for base blocks, that could be huge, over 20 megabytes or so, right? That data is probably not going to be available on chain anytime soon.
Yeah, I don't think it's a viable option for existing chains right now. I'm just throwing it in there as like, potential future path to how could we theoretically trust the proof more.
Do you know if native rollups also propose like a standard derivation pipeline or something equivalent?
I'm not sure. I think it would need to be pluggable in some way because each rollup has some, as you well know, have some custom things that they do. So yeah, I'm not sure. There's a link later on in the slides for the L2 Beats native rollup book. Okay. Okay, so you could add a second ZK proof. So we're going through the list of things that you could add as your second proof. It could be ZK. This is a great option because it's decentralized. It is more expensive. It could potentially be a optimistic ZK proof, which we can talk about the hybrid thing later if we have questions, or we have an expert on that here. One question you might ask is it diverse enough? So if there's a bug in one of your ZK proof systems, does it share enough with the other one that they both have the same bug? Okay, you could add a TE, and we've sort of talked about the benefits and disadvantages. Can't be decentralized, really. The stateful thing we've talked about, and verifying it on chain as well is potentially more complicated. The folks at Automata have done some great work on this, and I think if we've only got 6 minutes, but maybe if we get into more, they can talk about that. Okay. Actually, we will mention one more thing. No, we'll skip through it. Let's get to the proposal from Vitalik. So this is something that he posted earlier this year, which is basically 2 of 3 between optimistic ZK and TEE-based provers. And I'm wondering if anybody has questions or any comments on that, because I think there's a whole lot of things that you can dig into there. Why specifically those 3? Does optimistic belong in there? Is 2 of 2 okay? Does anyone have any thoughts or questions on that? Yes.
So my question is, for this fast finalization, currently we have 3 different options: the OP, ZK, and TEs. So as you mentioned, the OP has 7 days dispute, but the ZK and TE has they generate the proof very fast. I just kind of curious how does the OP work with the ZK and TEs?
So I think the idea is that because it's 2 of 3, if you have 2 fast options that agree, then you don't need to wait for the optimistic dispute game, and it could just go ahead. However, if there's a disagreement, then you still have 2 trustless options that can also potentially agree, even though it takes longer. Okay. So it's helpful for getting to stage 2. And then the other, I can take that. The other consideration is with stage 2, I think basically the main definition is if the proof systems disagree on chain, then you can still have a security council that can adjudicate. But it's obviously better if you can have 2 trustless systems that can do it without anyone intervening. We mentioned native rollups, and there's the out-to-beat native rollups book URL to take a look. Okay, we're just about at time. That is all that I had. Just to summarize, we want faster withdrawals because it makes all of the decentralized bridges cheaper and better options for users. It's not because they necessarily need to use the canonical bridge. And to do that, we need two things. We need faster proofs. That's the easy part. And then we need more trust in the proof itself. And that's the part that is a little more tricky and that multi-proofs achieves. Thanks. Do we have questions or comments? Yes, let me bring you a mic. Or do you want to come up? I'll bring the mic to you.
Maybe just one question. Like, what's the priority for the Optimism proof team right now? Because you mentioned so many options. I would like to know, like, in the near term, maybe 3 to 6 months, what's the priority for your team right now?
Yeah.
Thanks.
Well, I can't give you any like product announcements or anything, but I mean, we're definitely interested in fast withdrawals. So, and working iteratively is important. So I think whatever we do, it will be in stages, it will be done safely, and heading towards a multi-proof future. Any other questions? We've got a minute left. Yes, sir.
Actually, I have one comment regarding the TE on-chain verifications.
Yeah.
So, as you mentioned, for verifying the native TE proof on-chain is very expensive because the TE proof itself is very complex. You need to verify the signature, the certificate chain, and everything. So that will cost like millions of gas. To decrease the gas fee, we at Automata has proposed the ZK-based approach to verify the attestation report. Basically, we offload the TE attestation report verification to the ZK VM. We use the ZK, we use the attestation verifier in the ZK VM to verify the proof and generate the ZK proof. And then we send this ZK proof on chain, and it only costs like 10,000 gas.
Cool, that's awesome. I'm wondering, do you have any? Yeah, I've seen that there's TikTok actually has an open source tool to do this for AMD. Have you seen that? Yeah. Cool. So one thing that I would worry a little bit about is proof diversity. So if your ZK proof has a bug and your second proof is a TE, but if it relies on the same ZK, that might be a problem, perhaps, but that might be harder to exploit. So it depends on how decentralized it is. Yeah, that's very cool. Okay. We're at time. Thank you, everybody.
Okay. Hi everyone. Can you hear me? Nice, nice. I'm glad that it's not very overcrowded, so everyone have some space. Okay. Okay, guys. How many of you are liquidity providers into MMs? Oh, nice. That's like half of the, yeah, half of you. Okay, nice. So today we will talk about AMMs. We will see what are their like current inefficiencies and what we're proposing to do with this. So I will start with the question, what is capital efficiency? So yeah, there are like plenty of different research papers which are trying to measure capital efficiency and compare capital efficiency of different liquidity providing solutions, automated market makers. So I saw it's something like volumes per capital which AMM can attract. But on the other side, some papers claim this is a fees which can you attract per capital, or maybe yield, or maybe some other things which they measure capital efficiency. So reading some papers, I came up to conclusion that I do not understand what is capital efficiency, for real. So, okay, I tried to take a look from the other side. What inefficiencies we can find in existing AMM models and how we can address them. So the very first inefficiency which we tried to measure was how much of AMM capital is being utilized for real for trading. And we found out that these numbers is amount of liquidity which was never leaving pools for 90% of time during this year. This means that only 5% of Uniswap 2 liquidity was participated in actual trading. And yeah, for sure there are some concentrated liquidity protocols like Uniswap v2 and v3. This is a little bit different. It's like an average temperature in the hospital, but yeah, it still makes sense that this liquidity is not working. So yeah, I don't know, but from my point of view, this looks like inefficiency, and we will try to address it. By the way, this QR code would lead you to a Dune Analytics dashboard where you can verify everything. You will see SQL queries and more details, dashboard with details about percentiles of time of the amounts of the capital, shares of the capital being unutilized. Okay, on this slide, I'm showing how existing AMM pools approach is actually working. You may notice that for liquidity provider, providing liquidity for multiple different assets is actually a fragmentation of their capital. They have to fragment their most liquid assets. It's stable tokens. It's wrapped Ether, wrapped Bitcoin. The most liquid ones are being fragmented among different opportunities by providing liquidity to tens of different assets. That's also inefficiency from their point of view. And one more point here is that this capital is being locked inside the pools. What means being locked? You can withdraw it any block, yes, but being locked means that it's restricted in its functionality. It's DeFi disabled. This means that your funds in those pools are only able to be swapped, transferred to taker and from taker during swap. You can't use them for DeFi. You can't vote in DAO. You can't do nothing. And this is happening since 2017. And we're trying to challenge this approach to solve those three huge inefficiencies. This idleness, this fragmentation for liquidity provider, and this is huge amount of locked capital which is DeFi disabled. We're proposing new approach. We call it shared liquidity layer, Aqua, 1-inch Aqua. It works differently. For every liquidity provider, capital stays on their wallet, and AMMs are getting access to this liquidity on demand whenever it's actually needs to be swapped. And this is also unlocking your liquidity. If you have some DeFi-enabled assets, you could use them in DeFi, vote in DAO, do other things. How does it look like from AMM point of view? Whenever taker is coming to AMM for a swap, AMM is getting virtual balances from Aqua and using those balances to compute swap amounts. And then AMM using Aqua to get access to Maker liquidity by pulling assets from Maker wallet and pushing back. During pull and push, virtual balances are getting updated. So Aqua here is actually a settlement layer for transfers and also an accounting layer for virtual balances for AMMs. With unlocked liquidity, you could do much more than we even originally expected. You could vote in DAO, participate in V-tokenomics. You could leverage your liquidity with money market. I will show it on the next slide. Moreover, you could borrow liquidity on demand from money market right during the swap, but this would require some additional development from liquidity provider side. So how does liquidity leverage looks when you can turn your $1,000 into $3,000 of collateral and $2,000 of debt? So economically it makes sense. You still own 1K. You could achieve it with different approaches. You could deposit your 1K, borrow $800, deposit this $800, borrow more. What you borrowed, you have to put as collateral again and borrow more. And then the end, you could end up to having 3K collateral and 2K debt. It's still 3 minus 2. It's 1K. But you have 3 different stable tokens, which you could provide as a liquidity to 3 different pairs through Aqua to AMMs. And this means that each asset will participate in 2 pairs, like USDT to USDC and USDT to USDS, for example. This means that you will have 6K of virtual liquidity, but you came with only 1K. So you got 3K leverage through unlock feature and 2x more leverage through shared liquidity feature. So those capital efficiencies coming from those 2 different properties, sharing, shared, and unlocked, they're being compounded. So you could elevate your earnings as liquidity provider to like new heights. And you don't need to have any support from Aqua point of view. You just can open Aave, make this leverage, then open Aqua and make it work as a shared liquidity. The only thing which needs to be supported here from AMM side is that it should rather push first and pull second. Elsewise, it will not be able to exchange big amounts. Like you can't withdraw, pull 1K from this position because you will be under collateralized. It would lead to revert. So AMMs should support this feature to push first and pull then. So yeah, we also support this feature in our AMM, but you will see this next. So what is capital efficiency after what I showed to you? I think that capital efficiency is no more a protocol metric. It's metric of liquidity provider efforts and risk appetite. The more you work, the more you get, the more leverage you could have. So yeah, there is a thing called toxic flow and non-toxic flow in AMM space, and I think that we should redefine this. with a new thing which I call fair volumes and unfair volumes. I think that fair volumes is something what your protocol, your liquidity, your position, your strategy deserves from the market according to the prices it offers for the takers. And unfair volumes are volumes which were dedicated to some protocol without considering any other opportunities. Like if your front end is sending some volumes to your smart contracts without considering other options for better price, it's basically unfair volumes. So yeah, with Aqua, no flow is toxic anymore. And the next slide, the next section of my slides are about swap VM. This is actually our approach to build modular strategies in AMMs, and not only limited to AMMs, which could work on top of Aqua or without Aqua on their own. It's called VM because it's virtual machine. I always been asked for like few past days, like, what the virtual machine? Are you competing to EVM, to Solana VM, to Ton VM? Not really. That's actually name of architecture. This is basically now smart contract on Solidity for EVM, but this could be a protocol for any other blockchain. In terms of architecture, virtual machine means that it should operate with something called instructions. And here it is. It operates with instructions. So you could define your trading strategy with composable instructions which could serve different business logic you wish to achieve. Starting from bottom, you could use different swap formulas. You could use flat fees, dynamic fees. You could have concentration if you want. You could concentrate from one side, from both sides, whatever you wish. You could also have decay spread. Oh, wow. I will be more loud or something. Okay. So decay spread is something what we previously called Muni swap. Like 5 years ago, we invented thing which sells arbitrage opportunity as a Dutch auction. And now we're making it composable with other instructions. So you could get this arbitrage for Dutch auction for arbitrage traders with concentrated liquidity. Altogether, just place those instructions, select which of them you need, and you will get this highly composable behavior. So yeah, but how is that possible? That we made separate instructions which are not aware of each other. They're written completely separate, but what do they do? How they're built? So the core architecture invention is actually swap registers. It's data model. Here is it. It is, yeah. It's just 4 variables: balance in and out, amount in and out. Where in and out means direction of the assets. In assets means assets which are going to Maker wallet. Out means assets which are leaving Maker wallet at this specific swap. Balances are actually virtual balances from Aqua, or like real balances for something else. Meanwhile, amounts are provided by taker. The taker could provide one of the amounts. For example, if taker provide amount in, this does mean that they provide amount they wanna send, spend. And we have to compute with our instructions which amount we're gonna give them. If taker provided amount out, this means they specified how much they would get. And our instructions have to compute how much we should charge them. So, yeah. Next, I would provide 3 examples of instructions of how exactly they're working on this data model to achieve this composability, instruction level composability. The very first and very obvious one is constant product AMM. So it just makes sure that balances multiplication before swap is equal to balances multiplication after swap. it's obvious that balances after swap would be balance in plus amount in, and balance out minus amount out. So we can basically express amount in and amount out of this expression, and yeah, that's the only thing which this instruction compute. That was simple. Okay, let's go to something more complicated. Okay, concentrated liquidity. To concentrate liquidity, the only thing we need to do actually is to shift balances. We have to add some constants computed off-chain to balances. It's like 2 lines of code, but you could achieve concentrated liquidity. It is as simple as that. I'm not lying, almost. But there is a trick. If you would collect some fees with a flat fee instruction or dynamic fee instruction, this price range would increase. Yes, that's a problem. I mean, yeah, we could live with this, but some liquidity providers would prefer their strategy to maintain specific range. Okay, we have a separate instruction for this. This instruction we called XYC concentrate grow price range. And we wrote another one. We called it XYC concentrate grow liquidity. How it's different? The only difference is that after each swap, it's being readjusting those deltas by invariant increase, where invariant is just balances multiplication. So we just get new balances multiplied, divide by all balances multiplied, and readjust those deltas. So that was easy. We spent some time to came up to this, but it's actually a pretty simple code in Solidity. And yeah, regarding the Mooney swap, or how we call it, spread decay, I would explain you how does it work and how it's selling arbitrage opportunity within Dutch auction. Actually, when swap happens, you could see the starting points of red lines and blue lines. The starting point of red line is something where balances were originally. Both lines, both axes are balances. So some swap happens, and we're moving our balances to the beginning of the blue line. And then swap in the opposite direction does not immediately start from the red point, it's from the blue point. It still starts from the red point, from the origin. But we have like a conception of virtual balances, which are just starting linearly move from red point to blue point. You will see it's like a straight line here. And at some point, arbitrage is happening. And you could see it's like a line swap on this invariant curve. And you could see that real balances are following the same curve because it's balance change during swap. For virtual balances and real balances, it's the same. And then virtual balances again start decaying to real balances. And again, arbitrage opportunity happens. This happens multiple times until your real balances will meet virtual balances. And why we built this? We built this 5 years ago, and now we're imagining how we can achieve the same within instructions of this swap VM. So the only thing we have to do here is actually to make it feel like when we swap in back direction, we are pretending that previous swap never happened yet, or never happened fully. So it's being applied gradually, changing balances. And that's kind of Dutch auction, which lets liquidity provider to capture most of the value. When we had running this as a Mooney swap project 5 years ago, we made some measurements and we saw that arbitrage traders start to earn 10 times less. But they still do their function. They do rebalance the pool. Meanwhile, liquidity providers started to earn 2 times more. This actually means that liquidity providers and arbitrage traders, they usually earn comparable amounts of money. So yeah, This is one of the efficient mechanisms to capture value in favor of liquidity provider. And when we try to fit it into our instruction model of swap VM, it's just changing balances like this, increasing one of the balances and decreasing another balance to pretend previous swap not happened fully yet, and it's decaying over time. So this instruction is like 20, 30 lines of code, but it's like structured with a library a little bit. So yeah, if you would consider development of own AMM, you would usually want to implement some novel swap logic, some swap mechanism, some innovative idea. But to implement it, you have to deal with all those things. You have to write code for deposits, withdrawals, shares accounting, everything. Swap settlement itself, how exactly transfers should happen, in which direction. Is it flash swap or not flash swap? But now, if you would build on top of swap VM, you could try to implement your logic in a composable way, and you would get instruction level composability. This means that you could make your logic work in a modular way with every other instruction. For sure, not every instruction is compatible with everyone else. So yeah, it's a matter of programming on swap VM to build a proper strategies. Some instructions are for AMMs. Some instructions are for single directional swaps, like instruction for Dutch auction, or instruction for TWAP, or instruction for DCA, or any other instruction. Some of them are compatible with each other, some of them are not. So if you would be able to express your novel logic in this paradigm of this data model of input and output balances and amounts, you would be able to achieve composability with existing models. And that's pretty awesome from my point of view. And that's it. Thank you very much. I think we have time to answer questions. Any questions? Could you repeat the last phrase? Yeah, I would explain. 1 second. As far as I understood the question, because I can't hear really well, and I was told to not leave this perimeter. Yeah, it could end up that during the swap, virtual balances are fine, and some swap amounts are being computed, but at the end, maker does not have these amounts on their wallets. That's what you asked. Yeah, that's correct. But that's matter and business of taker to not to try to dig into liquidity which is not existing. The thing is that takers are getting smarter and smarter. Now we have all those aggregators, solvers networks, so it's getting more and more complicated to perform transactions on your own, especially when you interact with liquidity sources. It's pretty comparable to experience if you would try to fill someone's limit order. It should be also filled by someone else before you. It's pretty similar. So some of your strategies could stack with illiquidity. If you don't have liquidity on your balances, they would stack and they would not work. And if some liquidity will be dropped on your wallet, you could face immediate impermanent loss. Yeah, I would recommend liquidity providers to close their positions when they are illiquid and then refill wallets. But even if they have not closed them and they faced impermanent loss, it's still not a showstopper. I mean, it's impermanent. When or if prices would get back, you would be in the same exact situation as you always had liquidity, but you would have a little bit less fees because you were not able to trade them. So yeah, that's the answer. So yeah. More questions? Anyone else? Yes? Yeah, I would recommend to check out Aqua source code. It's actually 100 lines of code in Solidity. It's easy as that. I would start from truth of source, and then you could explore also documentation, you could explore our SDKs, but I personally see here is a huge opportunity to build AMMs and compete among AMMs not with TVL anymore, but with their logic, because you could attract liquidity by just getting shared access. And getting shared access is so much easier than attracting TVL. You would not believe me. More questions? I'm able to answer every question, I think. More questions? Yeah, we just announced it a few days ago, like 2 days ago. It's super new. And I'm getting now a lot of feedback for people who are into AMM space. It's not but much people, actually. I would say it's like 1,000-2,000 of engineers who are understanding this thing in like different levels of this understanding. And I think this is a huge opportunity. We would have bounties on the hackathon for builders to try to build anything on top of it. I mean, we do not understand yet what's possible when your finance are on your wallet and which protocols they could interact to. This feature of funds being unlocked from the pools is actually very powerful. And I think it's under-investigated, under-explored. And this is a huge opportunity for everyone to try to build something on top. We introduced, this is like a clean architecture distinction between layer providing shared access and between our own approach to AMM to be the best AMM. I don't see any way for us to be the best AMM. We see that there will be hundreds or thousands of different AMMs approaching these market inefficiencies differently. So yeah, I would welcome everyone to explore possibilities and build on top. This layer is permissionless for both liquidity providers and AMM builders. Yeah, you can connect me via X, Twitter. Yeah, I would reply. I have some slides there in threads, so yeah. Especially for those who came a little bit late, yeah. We also have my workshop on YouTube, and we have new recording, I think. Okay, thank you very much, guys.
Hello, everyone. Hi, thank you. I'm Tom Lehman from Facet, and I'm here to present on a topic called how to build a Stage 2 Ethereum rollup. And Facet is the only general purpose Stage 2 Ethereum rollup. This is from L2Beat, so those are my qualifications. And I'm here to talk you all through how to build a Stage 2 rollup, how we did it, how you can do it. But actually, this morning something happened. I clicked this button. This is the Sign the Trustless Manifesto pledge button. I'm sure you've seen this pledge. And the issue, if you read this pledge, you sign it, you have to pursue the cause of trustlessness. And actually, after I signed it, I realized I can't give the presentation I wanted to give. I have to give a new presentation, which is called How to Build a Trustless Ethereum Rollup, and why Stage 2 actually isn't enough. If you sign this manifesto, you are not allowed to give a presentation on how to build a Stage 2 rollup, and I'm going to tell you why. Okay, so to review, first, the stages, right? If you go on L2Beat, you can look this up, and here are the stages. You need to have something simple, and I really appreciate L2Beat, even though I don't agree with everything on there. Green, yellow, red. You have red, stage 0. That's the centralized stage, fully centralized. The green, stage 2, that's fully decentralized, or that's the idea. And then you have the kind of centralized in stage 1. If you see L2Beat today, you'll see many, many people in the kind of centralized bucket, and only two rollups in the stage 2 bucket. And Facet is the only general purpose one. But is stage 2 actually fully decentralized? And in fact, was Facet's goal even just to build a stage 2 rollup? Well, if you look at the criteria for stage 2, you can see there are a few elements. First two elements are pretty uncontroversial. Anyone should be able to exit the system, withdraw your money without operator help, so that's a fully open-proof system. You should be able to get transactions included without a centralized sequencer helping you, so that's forced transactions. And then there's this question of the exit window. Stage 2 rollups are still permitted to have admins, permitted to have privileged users who have more power than normal users, but this power is restrained by an exit window, by a restriction that if an admin wants to change the rules of the system in a way that hurts you, in a hostile way, they can't do it immediately. They have to give you time to react. A 30-day exit window is required. And so one question you might ask is, how good is this exit window? And particularly, how good is it for trustlessness if you sign the manifesto? If you didn't, you should listen before you sign it. So if you believe in the trustless manifesto, if you signed it, you cannot support exit windows. This is my contention here, and this is why you cannot support Stage 2 alone. And the reason for this is very simple. Trustlessness requires absolute guarantees. Okay, this is an absolute question. Is a system trustless, right? So one absolute guarantee is, this is a quote from the manifesto, censorship resistance. Any valid action can be included, right? Any valid action, okay? An exit window gives you this. For the next 30 days, during the exit window, any valid action can be included. So what is the difference between these two guarantees? Obviously, a lot, because of 31 days out, you have no guarantee. And so you could sign a modified version of the manifesto that restricts the guarantees to the duration of the exit window, and that's fine. But if you sign the main one, I don't think you can accept the fact that censorship resistance is not absolute. And so, the Trustless Manifesto also mentions landlords. Landlords are a good metaphor for this. You have a privileged person who has power over where you live, right? In the real world, that's a pretty powerful thing. On the blockchain, it's equally powerful when you think of someone in that position. And if a landlord can shut you out of your house, that's bad, even if they can give you a notice. Worse still, in the real world, you can take your stuff with you if you get evicted from your house. You can pack up your couch. But in the roll-up, there are things you can't take with you. So if you have assets that you've issued on the roll-up, if you have in-progress open bets, so perpetuals, if you have a vesting contract, you have things that are in progress that cannot be easily settled in time to leave, you can't exit with them. And in fact, we see a very surprising fact, which is that the Ethereum Foundation's own guidance is basically, don't issue assets on the L2. Don't create things you can't move when you get evicted, right? The Ethereum Foundation says, issue on the L1, bridge to the L2. This is on the Ethereum Foundation's guide to institutions using Ethereum, and this is, good guide for anyone using Ethereum today. Don't issue on the L2. That's what they're saying, right? And that is very valid advice, but you might want to ask yourself, do I want a system where I can't issue assets? And users have spoken. They're issuing a ton of assets on the L2, and in fact, you have to issue assets on the L2 when you use apps. Liquidity tokens are one very simple example of this. So this is a difference between the L1 and the L2 that we're going to unpack a little more. So perpetuals are a great example of this because the reason that perpetuals can live on a blockchain is because blockchains can have, at least nominally, this notion of perpetuity. It can go on forever. You can have open bet forever. There's no built-in system within the EVM that limits the duration of a contract's existence and ability to compute. 30 exit is not perpetual. A THRP is not a perp. Okay, so if you're thinking, wait, a THRP, is that as good? A 30-day, the point is, you could have a perpetual called a THRP, but no one would buy it. People want the perp, the real version, the perpetual that lasts the full duration of the open bet. So what we need is rule by code. That's what trustlessness is about. Rule by code, not by landlords, and that means we can't have landlords with power. Very basic. So no one should be able to change the code that governs your experience on a blockchain if that blockchain is going to be called trustless. No one. It's immutable. And so this is an interesting parallel. You might imagine, like, okay, there was a time on the iPhone when you had to manually update your apps, right? Every time you need to update your app, you'd open up your phone, go to the App Store, update your app. Very, very inconvenient, right? Then they released automatic updates. They, in fact, have automatic updates on your operating system, on your iPhone at least. You might ask yourself, why not do that for the Ethereum L1? Why not build in an upgrade ability into Ethereum nodes to enable the Ethereum Foundation to upgrade everyone's node went to the correct version, quote-unquote correct version, when there is a hard fork? So much more convenient than what has to happen today, which is you have to actively take an action. Obviously, despite convenience, people would reject this, right? Because the upgrade has to be voluntary, and the roll-up environment is not different from the L1 in this way. We should have the same demands. So we need immutable roll-ups. How do we do it? This is kind of the other side of it. So the first element is transaction inclusion. Can you do anything on the roll-up? And this is a fairly simple thing to fix, which is why it's kind of bizarre that today roll-ups are so admin-gated on forced inclusion, because the term forced inclusion sort of indicates that if you're forcing a transaction, you should be able to get around these admins. You should be able to do it anyway, even if the admins want to stop you. And yet, in typical roll-ups, forced inclusion flows through a smart contract that is admin-controlled and admin-upgradable, and this can be actually disabled. And so the first step, and this is like a very simple thing that I think roll-ups could do today, is to stop routing forced inclusion through an upgradable contract and do something different. Either use an immutable contract or an EOA address, an address with no code. And so you could do either, just by way of example of Facet, we use an EOA inbox for forced inclusion, which is this all zeros in phase 7, looks like Facet. This is nice because if there is a hard fork, users can continue to use the same inbox. They don't have to change contracts when the rules change because all of the rules are enforced off-chain. That's one way to do it. You could do an immutable contract. I think actually the best thing to do, and what we are working towards, is to enable any address to be the inbox for forced inclusion or any type of transaction sequencing. And the benefit to doing this is you can have the fewer restrictions you have, the greater potential you have to share data availability with other roll-ups. So if two people want to force transactions on two different roll-ups, they should be able to do that in the same Ethereum L1 transaction. So now we have the question of the proof system. So this is the main, we've got to protect users, training wheels. Standard roll-ups have proof systems that support messaging, but these cross-domain messaging proof systems have backdoors, or training wheels, as you might call them, that enable bugs to be fixed and the systems to be tuned for new upgrades. And so what you end up with is the entire structure of L2 to L1 messaging on these rollups governed by admins. And so no contract on the L1 can trust that unconditionally without also trusting the admins. And so what we need here, which is obvious based on what I've said so far, but also how are we going to do this, right? We need immutable proof systems. We need to get rid of upgrades on proof systems. We need to get rid of training wheels. We need to make them fully immutable, right? And so easy to say, right? Pretty easy to say, but but what about proof system bugs, right? This is the you can see a lot of discourse about this, right? Shout out to Tim Clancy, shout out to Sigil. I saw Tim going back and forth with many people on Twitter, but the idea keeps coming up. If you have an immutable proof system, or even a proof system with an exit window, how are we going to protect user funds? Because there are bugs, right? There are a lot of bugs. These are 3 random tweets. They all kind of relate to succinct, but you could Google for 2 seconds and see a million bugs, basically, for proof systems, and this is understandably scary. On the other side of the coin, you have the bugs with the multi-sig. They're not exactly bugs in the same sense, but they are surprising tricks that have been pulled that are impossible to anticipate in advance. And so in that respect, they are like bugs. They can't be found via inspection. Who could have ever foreseen how the Bybit hack would work? So from the first instance here, the proponents of upgradable admin proof systems have a little bit of a challenge. You can't just say the bugs are the problem. With the proof systems, the bugs with the multi-sigs are also the problem. And one question is, which bugs are worse, right? So you have Vitalik wrote this great blog post, and he said, here are some admittedly basic assumptions, right? His assumptions are not good, and he admitted them, right? But it's a good place to start. Shout out Vitalik, good for him for writing this. And he said, here is the model. Here's the model in terms of what you have to assume about how good the proof system is versus the corruptibility, so to speak, of the Security Council, and here's how you choose what stage you are on. Today, everyone universally, and there's only one general purpose stage 2 rollup, which proves this, everyone universally chooses assumptions that indicate that the greater risk is proof system bugs. But where are the models, right? So this is my shout out. It's like, if you believe that the proof system bugs are worse, you should make a model and spell out your assumptions and say why, because both things are bad. And so, just shouting out the Trustlessness Manifesto, is it an excuse or is it real? We don't actually know. I think the people who are believe proof system bugs are worse are genuinely trying to create good outcomes for users, but it's always tempting to have admin control. So anyway, the big picture here is proof systems are prone to bugs, which is tough. Multi-sigs are prone to bugs, which is tough. Which one you view as worse depends on how you model things, but since we're looking from the perspective of trustlessness, we are trying to eliminate the admins and see if the best we can do with a trustless system. And so how can we do that? So we're going to do that by kind of changing a little bit about how roll-ups work, or at least in terms of thinking about how what roll-ups are supposed to be and supposed to accomplish. Okay, so there is this, the issue with proof system bugs is that they lead to users losing funds, but they don't have to. Okay, proof systems are abstract ideas, and they don't necessarily, the consequences they have depend on interpretation. So when we talk about roll-ups, there's a lot of, often the term bridge gets 2 concepts conflated. So there is one side of bridging, which is messaging, communicating back and forth messages between L1 and L2 smart contracts. And there's another side of bridging, which is actually holding onto funds on the L1, putting funds into an escrow contract and removing them based on the messaging system. So the messaging system says, hey, L1 contract, this is me, your L2 friend contract, and I'm telling you to release some funds to Tom. And it's going through this proof system, secured messaging system. And then the L1 escrow is the app that decides what to do. So if the escrow hears this claim, hey, I'm the L2 friend of yours, give Tom money, the L1 escrow can decide what to do, and they don't have to trust messages blindly. The apps that are consuming the proof system are ultimately responsible for securing the user's funds. Okay, the proof system is at least in this vision, right, is a neutral kind of newswire that says, here's what the code says the truth is, and apps are responsible for adding safeguards or trusting messages. And this is better because users can choose apps, but they can't choose the rollup. Or rather, once they're on the rollup, they are committed to the rollup. And so you can have an app that chooses whether or not to trust a proof system or how many training wheels to add, and that app can be chosen or not chosen based on how good it is from the user standpoint versus the protocol-wide landlord. So this is how it works on the L1. All of this is modeled on the L1. So USDC, USDT on the L1, they're overlapping. Neither are trustless. Ethereum is not trustful because it has trustful stablecoins, right? What keeps the L1 trustless is that you don't have to use any of these escrows, right? You don't have to use any. You don't have to use any of these escrows. You don't have to use either. You can use one or not the other, and so forth. And the L1's job is to securely let you do what you want to do here, let you choose or not choose. And that's how L2 bridge escrows should work. L2 rollup should not be prescribing certain escrows, because if you prescribe it at the protocol level, then problems with the escrow infect the entire protocol. So this is how it already works today, in fact. So you can see the red is app-based escrow value, and the blue is rollup-based escrow value. And by rollup-based, I mean rollup escrows that rely completely on the canonical messaging system, that don't add additional training wheels. And as you can see, users prefer the app-driven sources of value. And this is something where there is one giant exception, though, and this is something that rollups do really need to change in order to fit this model, is the gas token bridge. So rollups can't get out of the business of escrowing funds if their gas token is minted in response to deposits to an escrow on the L1. In other words, you put ETH into an L1 escrow, and then you get a protocol level asset, a gas token on the L2, right? So this links the L2 to this escrow, and so having training wheels on this escrow means that now the entire protocol can be compromised. Notably, admins could, freeze gas issuance, or worse still, mint infinite gas themselves and freeze everyone out of transactions. And so, again, we have this issue of a single escrow admin becoming the landlord for the entire protocol, which is what we want to avoid. And so on Facet, we handle this by having a non-bridged gas token. So a gas token that is that has no admin, that has no L1 contract, that is capable of minting it, that is minted purely by code. So when a user takes an action on the L1, in this case, force including a Facet transaction, the amount of ETH they burned in that transaction is used to, is multiplied by a mint rate to determine the amount of L2 gas token, or FCT as we call it, the user gets. So there is no trust involved in getting the gas token. That means the gas token cannot be corrupted, which means that no admin can control the gas system and the rollup. And so this is a very big pill to swallow if you are used to using ETH on the L2, but if you want to avoid the trust associated with that, you really have no choice. Immutable rollups have three components. You need a mutable forced inclusion, you need a mutable proof system, and a proof system that doesn't say, hey, give this person money. It says, hey, this is what the L2 code says is true, right? That's it. The L1 has to decide whether that means to give the person money, to let the person withdraw from the escrow. And then we need an immutable gas token, which very likely today means that it's an algorithmically generated native token. We need to decouple escrows from the protocol, and L2Beat is already doing this. Luca Dono has a great post on L2Beat's discourse discussing how the notion of the canonical bridge in L2Beat is going to be shifted to refer more to the canonical messaging system versus any escrow attached to it. I think this is a very, very important move they're making. And then, yeah, just to sort of sum things up, like, this is not saying here is a better way to build a rollup, right? This is not saying if you build it this way, you're going to make a lot of money, your users are going to be happy. Same is true for Ethereum, right? You cannot say Ethereum is uniformly good. It is a, as the manifesto says, it is an enabler of freedom, right? Immutable rollups promise non-interference. Users might lose money, but if they do, it's because of their relationship with an app that ideally they chose, right? It's not because the rollup admin did something. They have control of their destiny, and this is exactly what the L1 hopes to do. Not make sure that you don't lose money, but make sure that you have the freedom without interference to engage with apps as you like. And so there's this guy, Diogenes the Cynic, famous guy from history. His friend once saw him and says, if you would eat lentils, if you would flatter the king, you wouldn't have to eat lentils. You would be able to eat better food because the king would give you better food. You'd be more comfortable. You wouldn't have to sit in the forum eating lentils. And Diogenes said, well, if you would just learn to eat lentils, you wouldn't have to flatter the Security Council, I mean king. And so that's kind of what this is about. You should choose what you want. Not every roll-up should endeavor to be immutable, but every roll-up that talks about trustlessness, every roll-up that talks about the values in the manifesto and aspires to live them, in my view, must be immutable. So whether you want to eat lentils or flatter is all good, but read the if you signed that pledge, you should take this immutability thing seriously. Thank you so much, and we have time, I think, for some questions. Don't run on each other. Just, get in line. You have to.
Hello, hello. All right, so we have a remote question being asked
I
here.
can't hear, actually. Is there a...
Yeah, you can just come over.
Like, at the stage here. Let me get...
Oh, no.
I got this. Yeah, this is good. Okay, try now.
Okay. The question, so I'm just the messenger here, but if we're encouraging L1 application safeguards on top of L2 proven messages, how do we prevent kicking the can of trustlessness down the road?
Yeah, that's a great question. So look, it'd be quite something if I could come up and say, here's the secret, right? Here is the answer where you can have and eat cake, where you can say, we are trustless, and we don't have to sacrifice anything. So, very valid criticism could be, okay, so, someone needs to be able to build a secure escrow, right? So if the protocol is not going to do it, someone has to do it, and so who's going to do it, right? I think that's very valid. And so this topic, this idea is not about saying, I recognize that by moving it out of the protocol, we might simplify things in one place, but create complexity in another place. Is that a net gain? I think yes, it is a net gain. And the reason is because users have choice about escrow, about apps they use. It's basically that users have choice about the apps that they use. And so you can have a competition between these escrows, and those will compete not just on the dimension of the level of trustlessness. They'll compete on the entire world of what users want to experience, right? Users really like stablecoins. Maybe stablecoins are quote-unquote bad or trustful or whatever, but users like them, so people compete for users. So users have the choice. The better escrows will quote-unquote better. The escrows that serve users will emerge, and crucially, there won't be an issue where a single escrow's problem kills every other app and every other escrow. So, the gas token escrow being this big example. Like, if that's compromised on a roll today, someone mints infinity gas to themselves, bids up the gas price to infinity, the whole thing is the whole network is broken. Whereas a single escrow is ideally contained. Now, you could say to that, well, even on the L1, that's not really true. If USDC got compromised, then Circle would force a hard fork through because they actually control the L1. So there's that issue too, but that's also on the L1. I'll say another thing that's bad about my idea here, another objection against myself, which is that if you have competition over escrows, and that competition, even if that does a good job in terms of serving user interests, you are still going to end up with chaos, right? Like, two escrows compete for the same asset, right? USDC, USDT are examples of this. It's the same asset. It's $1. If you have that on a grand scale, then you're gonna have a lot of chaos. Users are gonna be like, wait, I'm getting this token on the L2 that represents this same thing as this token, but they have different trust assumptions. So yes, this is a problem. That's another downside to this approach. You get more chaos. It's a lot simpler if you just say, price of admission at the door, the landlord, I trust the landlord controls everything, which is why I think not everyone should have a trustless L2. But if you are an app, you should weigh, is having the convenience of one asset representation, one security assumption, all the stuff, is that convenience better than a promise of non-interference? Non-interference meaning that, like, you know, it's all the stuff, good or bad, that happens is between you and your users, and so it's like non-interference versus that convenience, and there is no right answer, I would say, basically. Like, it's you have to choose as an app, as a user. No, you got. Yep.
What do you think about the future of immutable rollups like Facet in a world where we have also native rollups?
Right, so that's a great question. So what's up with native rollups? How do they relate? So native rollups, and there's a new EIP on this from the great Luca Dono. Shout out, Luca, if you're watching this in heaven. You know, my theory is when you die, you get to watch everything that's ever been said about you, or he could watch the live stream. But there's a new EIP about this that's either merged or not, and I've been trying to get a chance to sit down and like really pore over it. But like native rollups are happening. It's going to be a long time, right? It's going to be years from now. So in some sense, it kind of doesn't matter what we say, because like who knows what the world's going to look like then, and the history of Ethereum is being made, you know, today. But the promise of native rollups is the proof system is guaranteed to work, right? The proof system is guaranteed to work. That if the proof system of the rollup fails, the L1 has failed, and there'll be a hard fork and a social recovery. And so in a world where the proof system is guaranteed to work, then this changes. Then you could have a situation where everyone can blindly trust the same proof system because you're trusting the same thing you have to trust anyway. There's no additional assumption. And I think that would be great, and that would definitely change this a lot. I would say that native rollups do require, obviously, you know, if you know about native rollups, that they require certain restrictions. You have to have the exact state transition function that Ethereum has. So that's a major restriction. It has to be EVM equivalent in every way, right? So you can't have an extra precompile. Like when people say EVM equivalent, they often mean like basically that, but it has to be exactly the same. No precompiles, which means maybe less innovation for some rollups that want it, so that'll be relevant. But the main thing I would say is native rollups are great. They're down the road. They could change this calculus, but we have to like build them first, and we should all like try to do that. And I definitely want to contribute. And it would be great if this whole presentation were rendered completely obsolete by native rollups for sure.
Okay, so my question is...
Hold on a sec. My thing died here. Did I? Hold on, this died. Can I? So annoying. Sorry. So sorry. Annoying.
Can you hear me?
Yeah, good.
Good. So I would argue that not even Ethereum itself is immutable, right? So what do you think about, instead of having full immutability, have some decentralized form of governance? So not a single admin, but decentralized voting on upgrades.
Right, so it's a good question. So what's going on with even the L1? So part of it is I just want to say, hey, like L1's not my problem. Like I'm just trying to be as close to the L1 as possible. So that's one thing. Like I'm trying to say, let's get a rollup that doesn't have additional stuff. Like the L1 has code. You have to accept that, and norms. The rollup has code. Let's have there be nothing else on top of the L1 as the code is kind of the idea, versus like what's going on with the L1. But yeah, how decentralized is the L1 anyway? You know, this guy, Vitalik, very smart guy, has outsized interests. There is literally the case of the, stablecoin holders. Like there's a very famous blog post on Medium from like 5 years ago that says basically the L1 can never be forked again, right? This was 5 years ago. The L1 can never be forked again because of stablecoins. The DAO hack can never happen, or can never happen in that way, the recovery. And people on Twitter even recently were kind of talking about this question. What happens if Circle, wants to fork? And then it's like, welcome to 5 years ago. Like this is like a major thing. So yeah, I think the processes that lead to change on Ethereum are in practice rather centralized. Look where we are today. This is not just some random thing that happened. People planned this conference and planned, everything around it. And if you look at the EF's priorities, they drastically shape what happens, right? Like they put out these 3 priorities: scale the O1, scale the blobs, improve UX, and then that makes a difference in what is happening. But I still think it's pretty great that you, in the end of the day, at least you can keep running the old version. I think there's a soft power kind of thing there that keeps people in line. So I am still, I'm still very partial to the way it works, where at least you can't force someone to do it. I'm also, like my history in life, like before this, I was, I have a whole origin story with this company I made called Genius.com, which is a lyrics website, and I was the CEO of that. And so in that many-year thing, I had all these experiences with like company governance, how you organize a company, and board and corporate governance. And this was a pretty small company in relation to what I'm sure many people out here have even like run or been in contact with. And like, it's just so hard. It is so hard to do good governance, and there's a reason why corporations in America, are run by dictators. Basically, like that is kind of the the dominant mode for a reason. So I think it's just very hard to do like the DAO type thing. But this is somewhat of my bias, maybe. But yeah, that's kind of how I feel about the L1. Shout out L1. I still love you.
Thanks. Yeah.
Yeah. Oh, there's only one more question from. Okay, no more. Only one? What? No? Okay. Anyway, thank you all so much. I really appreciate it. I'm Tom Lehman from Facet. Please hit me up on Twitter at dumbnamenumbers. Working on changing that handle pending Twitter's marketplace, but you can always hit me up. Really appreciate any feedback you have in this presentation, or if you want to collaborate on anything relating to immutable rollups. If you are, or any rollup even with an exit window, right? If you are listening to this, you are in the top 0.0001% of people who care about decentralization and trustlessness. So even if you even if you disagree with a lot of what I'm saying, like we probably agree on a ton. So please hit me up, and thanks so much. Have a great Devconnect. Peace.